Picture of Antarctica showing water, mountain, and iceberg peaks under a bright blue sky credit. Andreas Campbell's chapter outline 1 Real numbers. Algebra Essentials 1 Exponents and Scientific Notation 1. 3 Radicals and Rational Exponents 1. 4 Polynomials 1. 5 Factoring Polynomials 1. 6 Rational Expressions. It's a cold day in Antarctica. In fact, it's always a cold day in Antarctica. Earth's southernmost continent, Antarctica experiences the coldest, driest, and windiest conditions known. The coldest temperature ever recorded, over 100 degrees below zero on the Celsius scale, was recorded by remote satellite. It is no surprise, then, that no native human population can survive the harsh conditions. Only explorers and scientists brave the environment for any length of time. Measuring and recording the characteristics of weather conditions in Antarctica requires a use of different kinds of numbers. For tens of thousands of years, humans have undertaken methods to tally, track, and record numerical information. While we don't know much about their usage, the Lebombo bone, dated to about 35,000 BCE, and the Ashango bone, dated to about 20,000 BCE, are among the earliest mathematical artifacts. Found in Africa, their clearly deliberate groupings of notches may have been used to track time, moon cycles, or other information. Performing calculations with them and using the results to make predictions requires an understanding of relationships among numbers. In this chapter, we will review sets of numbers and properties of operations used to manipulate numbers. This understanding will serve as prerequisite knowledge throughout our study of algebra and trigonometry. Learning objectives in this section, you will classify a real number as a natural, whole, integer, rational, or irrational number. Perform calculations using order of operations. Use the following properties of real numbers: commutative, associative, distributive, inverse, and identity. Evaluate algebraic expressions. Simplify algebraic expressions. It is often said that mathematics is the language of science. If this is true, then an essential part of the language of mathematics is numbers. The earliest use of numbers occurred 100 centuries ago in the Middle East to count or enumerate items. Farmers, cattle herders, and traders used tokens, stones, or markers to signify a single quantity. A sheaf of grain, a head of livestock, or a fixed length of cloth, for example. Doing so made commerce possible, leading to improved communications and the spread of civilization. 3,000 to 4,000 years ago, Egyptians introduced fractions. They first used them to show reciprocals. Later, they used them to represent the amount when a quantity was divided into equal parts. But what if there were no cattle to trade, or an entire crop of grain was lost in a flood? How could someone indicate the existence of nothing? From earliest times, people had thought of a base state, while counting and used various symbols to represent this null condition. However, it was not until about the 5th century CE in India that 0 was added to the number system and used as a numeral in calculations. Clearly, there was also a need for numbers to represent loss or debt. In India, in the 7th century CE, negative numbers were used as solutions to mathematical equations and commercial debts. The opposites of the counting numbers expanded the number system even further. Because of the evolution of the number system, we can now perform complex calculations using these and other categories of real numbers. In this section, we will explore sets of numbers, calculations with different kinds of numbers, and the use of numbers in expressions. Classifying a real number, the numbers we use for counting or enumerating items are the natural numbers. 1, 2, 3, 4, 5, and so on. We describe them in set notation as 123, where the ellipsis indicates that the numbers continue to infinity. The natural numbers are, of course, also called the counting numbers. Any time we enumerate the members of a team, count the coins in a collection, or tally the trees in a grove, we are using the set of natural numbers. The set of whole numbers is the set of natural numbers plus 0. 123. The set of integers adds the opposites of the natural numbers to the set of whole numbers. -3, -2, -1, 0. 1, 2, 3. It is useful to note that the set of integers is made up of 3 distinct subsets: negative integers, 0, and positive integers. In this sense, the positive integers are just the natural numbers. Another way to think about it is that the natural numbers are a subset of the integers. -3, -2, -1, negative integers 0, 0, 1, 2, 3. Positive integers, the set of rational numbers, is written as letter 1d45a, letter 1d45b, letter 1d45a, a nd letter 1d45b, a re integers, and letter 1d45b, not equal to 0. Notice from the definition that rational numbers are fractions, or quotients, containing integers in both the numerator and the denominator, and the denominator is never 0. We can also see that every natural number, whole number, and integer is a rational number with a denominator of 1. Because they are fractions, any rational number can also be expressed as a terminating or repeating decimal. Any rational number can be represented as either a terminating decimal, 158 equals 1, 875, or ba repeating decimal, 411 equals 0. 36,363,636 equals 0. 36, we use a line drawn over the repeating block of numbers instead of writing the group multiple times. Example 1. Writing integers as rational numbers, write each of the following as a rational number. A7b0c. 8. Solution, write a fraction with the integer in the numerator and 1 in the denominator. A7 equals 71b0 equals 0, 1c minus 8 equals minus 80. 1. Try it. 1. Write each of the following as a rational number. A11b3c. For example 2, identifying rational numbers, write each of the following rational numbers as either a terminating or repeating decimal. A-57b, 155c, 1325. Solution, write each fraction as a decimal by dividing the numerator by the denominator. A-57 equals minus 0. 714,285. A repeating decimal B155 equals 3 or 3. 0. A terminating decimal C1325 equals 0. 52. A terminating decimal. Try it. 2. Write each of the following rational numbers as either a terminating or repeating decimal. A6817B 813 C minus 1720. Irrational numbers. At some point in the ancient past, someone discovered that not all numbers are rational numbers. A builder, for instance, may have found that the diagonal of a square with unit sides was not 2 or even 32, but was something else. Or a garment maker might have observed that the ratio of the circumference to the diameter of a roll of cloth was a little bit more than 3, but still not a rational number. Such numbers are said to be irrational because they cannot be written as fractions. These numbers make up the set of irrational numbers. Irrational numbers cannot be expressed as a fraction of two integers. It is impossible to describe this set of numbers by a single rule except to say that a number is irrational if it is not rational. So we write this as shown. Letter 210e, letter 210e, is not a rational number. Example 3. Differentiating rational and irrational numbers, determine whether each of the following numbers is rational or irrational. If it is rational, determine whether it is a terminating or repeating decimal. A25 square B 339C 11 square D 1734 E0. 3,030,3,030,3,333,333. Solution, A25 square. This can be simplified as 25 square equals 5. Therefore, 25 square is rational. B 339, because it is a fraction of integers, 339 is a rational number. Next, simplify and divide. 339 equals 331,193 equals 113 equals 3. 6. So, 339 is rational and a repeating decimal. C 11 square. 11 square is irrational because 11 is not a perfect square and 11 square cannot be expressed as a fraction. D 1734. Because it is a fraction of integers, 1734 is a rational number. Simplify and divide. 1,734 equals 171,342 equals 12 equals 0. 5. So, 1734 is rational and a terminating decimal. E. 3,033,033,303,333 is not a terminating decimal. Also note that there is no repeating pattern because the group of threes increases each time. Therefore, it is neither a terminating nor a repeating decimal, and hence not a rational number. It is an irrational number. Try it 3. Determine whether each of the following numbers is rational or irrational. If it is rational, determine whether it is a terminating or repeating decimal. A 777, B 81 square C4. 27,027,002,700,027. D 9113 E 39 square real numbers given any number n. We know that n is either rational or irrational. It cannot be both. The sets of rational and irrational numbers together make up the set of real numbers. As we saw with integers, the real numbers can be divided into 3 subsets: negative real numbers, 0, and positive real numbers. Negative and positive real numbers include fractions, decimals, and irrational numbers according to their algebraic sign. Plus, or 0 is considered neither positive nor negative. The real numbers can be visualized on a horizontal number line with an arbitrary point chosen as 0, with negative numbers to the left of 0 and positive numbers to the right of 0. A fixed unit distance is then used to mark off each integer or other basic value on either side of 0. Any real number corresponds to a unique position on the number line. The converse is also true. Each location on the number line corresponds to exactly one real number. This is known as a one-to-one correspondence. We refer to this as the real number line as shown in Figure 1. A number line that is marked from -5 to 5. Figure 1, the real number line example. 4 classifying real numbers classify each number as either positive or negative, and as either rational or irrational. Does the number lie to the left or the right of 0 on the number line? A-103b, 5 square c minus 289 square d, minus 6, letter 1 d70b, E0. 615,380, 4,615,384. Solution A-103 is negative and rational. It lies to the left of 0 on the number line. B5 square is positive and irrational. It lies to the right of 0. C minus 289 square equals minus 172 square equals minus 17 is negative and rational. It lies to the left of 0. D minus 6 letter 1 D70b is negative and irrational. It lies to the left of 0. E0. 615,380, 4,615,384 is a repeating decimal, so it is rational and positive. It lies to the right of 0. Try it 4. Classify each number as either positive or negative, and as either rational or irrational. Does the number lie to the left or the right of 0 on the number line? A 73 square b minus 11. 411,411,411. C 4719 d minus 5 square root 2 E6. 210,735 sets of numbers as subsets beginning with the natural numbers. We have expanded each set to form a larger set, meaning that there is a subset relationship between the sets of numbers we have encountered so far. These relationships become more obvious when seen as a diagram, such as Figure 2. A large box labeled Real Numbers encloses 5 circles. 4 of these circles enclose each other, and the other is separate from the rest. The innermost circle contains 1, 2, 3, and the circle enclosing that circle contains 0. W. The circle enclosing that circle contains -3, -2, -1. I. The outermost circle contains n not equal to 0. Q. The separate circle contains pi, square root of 2, etc. Q. Figure 2 sets of numbers n, the set of natural numbers w, the set of whole numbers I, the set of integers q, the set of rational numbers q, the set of irrational numbers, sets of numbers. The set of natural numbers includes the numbers used for counting, 123. The set of whole numbers is the set of natural numbers plus 0, 123. The set of integers adds the negative natural numbers to the set of whole numbers, -3, -2, -1, 0, 1, 2, 3. The set of rational numbers includes fractions written as letter 1d45a, letter 1d45b, letter 1d45a, a nd letter 1d45b, a re integers and letter 1d45b not equal to 0. The set of irrational numbers is the set of numbers that are not rational, are non-repeating, and are non-terminating. Letter 210e, letter 210e, is not a rational number. Example 5, differentiating the sets of numbers classify each number as being a natural number n, whole number w, integer I, rational number q, and or irrational number q. A 36 square b, 83c, 73 square d minus 63. 2,121,121,112. Solution, NWIQQ A 36 square equals 6xxxxb 83 equals 2. 6xc. 73 square xd. 6xxe3 2,121,121,112. X try it 5 classify each number as being a natural number n, whole number w, integer I, rational number q, and or irrational number q. A minus 357, b, 0c 169 square d, 24 square e4. 763,763,763. Performing calculations using the order of operations when we multiply a number by itself. We square it or raise it to a power of 2. For example, 42 equals 4 equals 16. We can raise any number to any power. In general, the exponential notation n means that the number or variable a is used as a factor n times. Letter 1d44e, letter 1d45b equals letter 1d44e, letter 1d44e, letter 1d44e, letter 1d44e, letter 1d45b factors in this notation. N is read as the nth power of a, or a to the n where a is called the base, and n is called the exponent. A term in exponential notation may be part of a mathematical expression, which is a combination of numbers and operators, i.e. plus addition, subtraction, times multiplication, division. For example, 24 plus 6, 23 minus 42 is a mathematical expression. To evaluate a mathematical expression, we perform the various operations. However, we do not perform them in any random order. We use the order of operations. This is a sequence of rules for evaluating such expressions. Recall that in mathematics we use parentheses, brackets, and braces to group numbers and expressions so that anything appearing within the symbols is treated as a unit. Additionally, fraction bars, radicals, and absolute value bars are treated as grouping symbols. When evaluating a mathematical expression, begin by simplifying expressions within grouping symbols. The next step is to address any exponents or radicals. Afterward, perform multiplication and division from left to right, and finally addition and subtraction from left to right. Let's take a look at the expression provided. 24 plus 6, 23 minus 42, there are no grouping symbols, so we move on to exponents or radicals. The number 4 is raised to a power of 2, so simplify 42 as 16. 24 plus 6, 23 minus 4,224, plus 6, 23 minus 60 next. Perform multiplication or division, left to right. 24 plus 6, 23 minus 1,624, plus 4 minus 16 lastly. Perform addition or subtraction, left to right. 24 plus 4 minus 1,628 minus 1,612, therefore, 24 plus 6, 23 minus 42 equals 12. For some complicated expressions, several passes through the order of operations will be needed. For instance, there may be a radical expression inside parentheses that must be simplified before the parentheses are evaluated. Following the order of operations ensures that anyone simplifying the same mathematical expression will get the same result. Order of operations, operations in mathematical expressions, must be evaluated in a systematic order, which can be simplified using the acronym PEMDAS. P parentheses, E exponents, M multiplication, and D division, A addition, and S subtraction. How to given a mathematical expression, simplify it using the order of operations. Step 1. Simplify any expressions within grouping symbols. Step 2. Simplify any expressions containing exponents or radicals. Step 3. Perform any multiplication and division in order, from left to right. Step 4. Perform any addition and subtraction in order, from left to right. Example 6. Using the order of operations, use the order of operations to evaluate each of the following expressions. A 32, 2 minus 4. 6 plus 2 B 52 minus 40 7 minus 11 minus 2 square C 6 minus 5 minus 8 plus 3 4 minus 1 D 14 minus 3 22 5 minus 32 E 7 5 3 minus 2 6 minus 3 minus 42 plus 1 Solution A 322 minus 4 6 plus 2 equals 6 2 minus 4 8 36 minus 4 8 36 minus 324 Simplify. Parentheses. Simplify exponent. Simplify multiplication, simplify subtraction. B 52 minus 40, 7 minus 11 minus 2, square equals 52 minus 47 minus 9, square 52 minus 47 minus 325 minus 47 minus 3217 minus 33 minus 30, simplify grouping symbols. Radical. Simplify radical, simplify exponent, simplify subtraction in numerator. Simplify division, simplify subtraction. Note that in the first step, the radical is treated as a grouping symbol, like parentheses. Also, in the third step, the fraction bar is considered a grouping symbol, so the numerator is considered to be grouped. C 6 minus 5 minus 8 plus 3 4 minus 1 equals 6 minus 3 plus 3 3, 6 minus 3 plus 3 3, 6 minus 3 plus 912 Simplify inside grouping symbols. Simplify absolute value. Simplify multiplication. Simplify addition. D 14 minus 322 5 minus 32 equals 14 minus 322 5 minus 914 minus 610 minus 9818. Simplify exponent. Simplify products. Simplify differences. Simplify quotient. In this example, the fraction bar separates the numerator and denominator, which we simplify separately until the last step. E7, 5 3 minus 2, 6 minus 3 minus 42 plus 1 equals 7, 15 minus 2, 3 minus 42 plus 17, 15 minus 2, 3 minus 16, plus 17, 15 minus 2 minus 13, plus 1105 plus 26 plus 1132, simplify inside parentheses. Simplify exponent, subtract, multiply, add. Try at 6. Use the order of operations to evaluate each of the following expressions. A 52 minus 42, square plus 7, 5 minus 4, 2b 1 plus 7 5 minus 8 49 minus 6 c1, 8 minus 4, 3 plus 0. 415 plus 10 square d 12 5 32 minus 72 plus 1392 e 3 minus 8 2 minus 4 minus 3 minus 8. Using properties of real numbers for some activities we perform, the order of certain operations does not matter, but the order of other operations does. For example, it does not make a difference if we put on the right shoe before the left or vice versa. However, it does matter whether we put on shoes or socks first. The same thing is true for operations in mathematics. Commutative properties. The commutative property of addition states that numbers may be added in any order without affecting the sum. Letter 1 D44E plus letter 1 D44F equals letter 1 D44F plus letter 1 D44E. We can better see this relationship when using real numbers. Minus 2 plus 7 equals 5 and 7 plus minus 2 equals 5. Similarly, the commutative property of multiplication states that numbers may be multiplied in any order without affecting the product. Letter 1 D44E letter 1 D44F equals letter 1 D44F letter 1 D44E again. Consider an example with real numbers. Minus 11, minus 4 equals 44, and minus 4. Minus 11 equals 44. It is important to note that neither subtraction nor division is commutative. For example, 17 minus 5 is not the same as 5 minus 17. Similarly, 20 divided by 5 not equal to 5 divided by 20. Associative properties. The associative property of multiplication tells us that it does not matter how we group numbers when multiplying. We can move the grouping symbols to make the calculation easier, and the product remains the same. Letter 1 D44E, letter 1d44f letter 1d450 equals letter 1d44 letter 1d44f letter 1d450. Consider this example. 3 4 5 equals 60 and 3 4 5 equals 60. The associative property of addition tells us that numbers may be grouped differently without affecting the sum. Letter 1d44e plus letter 1d44f plus letter 1d450 equals letter 1d44e plus letter 1d44f plus letter 1d450. This property can be especially helpful when dealing with negative integers. Consider this example. 15 plus minus 9 plus 23 equals 29 and 15 plus minus 9 plus 23 equals 29 are subtraction and division associative. Review these examples. 8 minus 3 minus 15 8 minus 12 20 equals not 8 minus 3 minus 155 minus 15 minus 1064 divided by 8 divided by 4 64 divided by 232 equals not equal to 64 divided by 8 divided by 48 divided by 42. As we can see, neither subtraction nor division is associative. Distributive property. The distributive property states that the product of a factor times a sum is the sum of the factor times each term in the sum. Letter 1d44e, letter 1d44f plus letter 1d450 equals letter 1d44e, letter 1d44f plus letter 1d44e, letter 1d450. This property combines both addition and multiplication, and is the only property to do so. Let us consider an example. The number 4 is separated by a multiplication symbol from a bracketed expression reading 12 plus negative 7. Arrows extend from the 4 pointing to the 12 and negative 7 separately. This expression equals 4 times 12 plus 4 times negative 7. Under this line, the expression reads 48 plus negative 28. Under this line, the expression reads 20 as the answer. Note that 4 is outside the grouping symbols, so we distribute the 4 by multiplying it by 12, multiplying it by 7, and adding the products. To be more precise when describing this property, we say that multiplication distributes over addition. The reverse is not true, as we can see in this example. 6 plus 3 5, 6 plus 15 21 equals not equal to 6 plus 3, 6 plus 5, 9, 11 99. A special case of the distributive property occurs when a sum of terms is subtracted. Letter 1d44e minus letter 1d44f equals letter 1d44e plus minus letter 1d44f. For example, consider the difference 12 minus 5 plus 3. We can rewrite the difference of the two terms 12 and 5 plus 3 by turning the subtraction expression into addition of the opposite. So instead of subtracting 5 plus 3, we add the opposite, 12 plus minus 1. 5 plus 3, now distribute minus 1 and simplify the result. 12 minus 5 plus 3 equals 12 plus minus 1. 5 plus 3 12 plus, minus 1 5 plus, minus 1 3 12 plus, minus 8. For this seems like a lot of trouble for a simple sum, but it illustrates a powerful result that will be useful once we introduce algebraic terms. To subtract a sum of terms, change the sign of each term and add the results. With this in mind, we can rewrite the last example. 12 minus 5 plus 3 equals 12 plus, minus 5 minus 3 12 plus, minus 8. For identity properties, the identity property of addition states that there is a unique number, called the additive identity, 0, that, when added to a number, results in the original number. Letter 1d44e plus 0 equals letter 1d44e. The identity property of multiplication states that there is a unique number, called the multiplicative identity, 1, that, when multiplied by a number, results in the original number. Letter 1d44e, 1 equals letter 1d44e. For example, we have minus 6, plus 0 equals minus 6, and 23 1 equals 23. There are no exceptions for these properties. They work for every real number, including 0 and 1 inverse properties. The inverse property of addition states that, for every real number a, there is a unique number, called the additive inverse, or opposite, denoted by minus a, that, when added to the original number, results in the additive identity, 0. Letter 1d44e plus, minus letter 1d44e, equals 0, for example, if letter 1d44e equals -8, the additive inverse is 8, since -8 plus 8 equals 0. The inverse property of multiplication holds for all real numbers except 0 because the reciprocal of 0 is not defined. The property states that, for every real number a, there is a unique number, called the multiplicative inverse, or reciprocal, denoted 1a, that, when multiplied by the original number, results in the multiplicative identity, 1. Letter 1d44e, 1 letter 1d44e equals 1, for example. If letter 1d44e equals -23, the reciprocal, denoted 1a, is -32 because letter 1d44e, 1 letter 1d44e equals -23. -32 equals 1 properties of real numbers. The following properties hold for real numbers, a, b, and c. Addition, multiplication, commutative property letter 1d44e plus letter 1d44f equals letter 1d44f plus letter 1d44e letter 1d44e letter 1d44f equals letter 1d44f letter 1d44e. Associative property letter 1d44e plus letter 1d44f plus letter 1d450 equals letter 1d44e plus letter 1d44f plus letter 1d450. Letter 1d44e, letter 1d44f letter 1d450 equals letter 1d44e letter 1d44f. Letter 1d450, distributive property letter 1d44e, letter 1d44f plus letter 1d450 equals letter 1d44e letter 1d44f plus letter 1d44e letter 1d450. Identity property, there exists a unique real number called the additive identity, 0, such that, for any real number a letter 1d44e plus 0 equals letter 1d44e, there exists a unique real number called the multiplicative identity, 1, such that, for any real number a letter 1d44e, 1 equals letter 1d44e inverse property, every real number a has an additive inverse, or opposite, denoted a, such that letter 1d44e plus minus letter 1d44e equals 0. Every non-zero real number a has a multiplicative inverse, or reciprocal, denoted 1a, such that letter 1d44e, 1 letter 1d44e, equals 1. Example 7. Using properties of real numbers, use the properties of real numbers to rewrite and simplify each expression. State which properties apply. A 3 6 plus 3 4 b, 5 plus 8 plus -8, c 6 minus 15 plus 9, d 47, 23 74, e 100 0, 75 plus -2, 38. Solution 3 6 plus 3 4 equals 3, 6 plus 4, 3 1030. Distributive property. Simplify. B 5 plus 8 plus -8 equals 5 plus 8 plus -8, 5 plus 0, 5. Associative property of addition. Inverse property of addition. Identity property of addition. C6 minus 15 plus 9 equals 6 plus -15 plus -9, 6 plus -24 -18. Distributive property. Simplify. D 47, 2374 equals 47, 74 23, 47 74, 230, 2323. Commutative property of multiplication. Associative property of multiplication. Inverse property of multiplication. Identity property of multiplication. E 100 0, 75 plus -2, 38 equals 100 0, 75 plus 100 -2, 38, 75 plus -238 -163. Distributive property. Simplify. Try it 7. Use the properties of real numbers to rewrite and simplify each expression. State which properties apply. A -235 11 -523, b 5 6, 2 plus 0 4, c 18 minus 7 -15, d 1718 plus 49 plus -1718, e 6 -3 plus 6 3. Evaluating algebraic expressions. So far, the mathematical expressions we have seen have involved real numbers only. In mathematics, we may see expressions such as letter 1d465 plus 5, 43 letter 1d70b letter 1d45f3, or 2 letter 1d45a 3 letter 1d45b 2 square. In the expression x plus 5, 5 is called a constant because it does not vary, and x is called a variable because it does. In naming the variable, ignore any exponents or radicals containing the variable. An algebraic expression is a collection of constants and variables joined together by the algebraic operations of addition, subtraction, multiplication, and division. We have already seen some real number examples of exponential notation, a shorthand method of writing products of the same factor. When variables are used, the constants and variables are treated the same way. -3, 5, 2, 7, 3 equals minus 3, minus 3, minus 3, minus 3, minus 3, 2, 7, 2, 7, 2, 7, letter 1d4, 6, 5, 5, letter 1d4, 6, 6, letter 1d4, 6, 7, 3 equals, letter 1d4, 6, 5, 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 letter 1d4, 6, 6, letter 1d4, 6, 7, letter 1d4, 6, 6, letter 1d4, 6, 7, letter. In each case, the exponent tells us how many factors of the base to use, whether the base consists of constants or variables. Any variable in an algebraic expression may take on or be assigned different values. When that happens, the value of the algebraic expression changes. To evaluate an algebraic expression means to determine the value of the expression for a given value of each variable in the expression. Replace each variable in the expression with the given value, then simplify the resulting expression using the order of operations. If the algebraic expression contains more than one variable, replace each variable with its assigned value and simplify the expression as before. Example 8, describing algebraic expressions, lists the constants and variables for each algebraic expression. Ax plus 5b 43 letter 1d70b letter 1d45f, 3c2 letter 1d45a 3 letter 1d45b 2 square try. It 8 lists the constants and variables for each algebraic expression. A2 letter 1d70b letter 1d45f, letter 1d45f plus letter 210e, letter 24d12, L plus W. C4y3 plus y. Example 9, evaluating an algebraic expression at different values, evaluate the expression 2 letter 1d465 minus 7 for each value for x. A letter 1d465 equals 0, B letter 1d465 equals 1, C letter 1d465 equals 12, D letter 1d465 equals minus 4. Solution. Substitute 0 for x. 2 letter 1d465 minus 7 equals 2, 0. Minus 70 minus 7 minus 7 B. Substitute 1 for x. 2 letter 1d465 minus 7 equals 2. 1 minus 72 minus 7 minus 5c, substitute 12 for x. 2 letter 1d465 minus 7 equals 2, 12, minus 71 minus 7 minus 6, d. Substitute minus 4 for x. 2 letter 1d465 minus 7 equals 2. Minus 4 minus 7 minus 8 minus 7 minus 15. Try. It 9 evaluate the expression 11 minus 3 letter 1d466 for each value for y. A letter 1d466 equals 2, B letter 1d466 equals 0, C letter 1d466 equals 23d. Example 10, evaluating algebraic expressions. Evaluate each expression for the given values. Ax plus 5 for letter 1d465 equals minus 5b theta letter 1d461 minus 1. For letter 1d461 equals 10c43 letter 1d70b letter 1d45f 3. For letter 1d45f equals 5da plus ob plus b. For letter 1d44e equals 11. Letter 1d44f equals minus 8e2 letter 1d45a 3 letter 1d45b 2 square. For letter 1d45a equals 2. Letter 1d45b equals 3. Solution. Substitute minus 5 for x. Letter 1d465 plus 5 equals minus 5 plus 50b. Substitute 10 for t. Yeah. C. Substitute 5 for r. 43 letter 1d70b letter 1d45f 3 equals 43 letter 1d70b 5. 343 letter 1d70b 125 5003 letter 1d70b. D. Substitute 11 for A and 8 for B. Letter 1d44e plus letter 1d44e letter 1d44f plus letter 1d44f equals 11 plus 11 minus 8 plus minus 8 11 minus 88 minus 8 minus 85 substitute 2 for m and 3 for n. 2 letter 1d45a 3 letter 1d45b 2 square equals 2 2 3 3 2 square 2 8 9 square 144 square 12 try it 10 evaluate each expression for the given values. A letter 1d466 plus 3 letter 1d466 minus 3 for letter 1d466 equals 5b7 minus 2 letter 1d461. For letter 1d461 equals minus 2c13 letter 1d70b letter 1d45f 2. For letter 1d45f equals 11d. P to letter 1d45e 3. For letter 1d45d equals minus 2. Letter 1d45e equals 3e4. Letter 1d45a minus letter 1d45b. Minus 5 letter 1d45b minus letter 1d45a. For letter 1d45a equals 23. Letter 1d45b equals 13. Formulas. An equation is a mathematical statement indicating that two expressions are equal. The expressions can be numerical or algebraic. The equation is not inherently true or false, but only a proposition. The values that make the equation true, the solutions, are found using the properties of real numbers and other results. For example, the equation 2 letter 1d465 plus 1 equals 7 has the solution of 3 because when we substitute 3 for x in the equation, we obtain the true statement 2, 3 plus 1 equals 7. A formula is an equation expressing a relationship between constant and variable quantities. Very often, the equation is a means of finding the value of one quantity, often a single variable, in terms of another or other quantities. One of the most common examples is the formula for finding the area A of a circle in terms of the radius r of the circle. Letter 1d434 equals letter 1d70 b letter 1d45f2. For any value of r, the area A can be found by evaluating the expression letter 1d70 b letter 1d45f2. Example 11, using a formula A right circular cylinder with radius r and height h has the surface area S in square units. Given by the formula letter 1d446 equals 2 letter 1d70 b letter 1d45f, letter 1d45f plus letter 210e. See figure 3. Find the surface area of a cylinder with radius 6 in and height 9 in. Leave the answer in terms of letter 1d70b. A right circular cylinder with an arrow extending from the center of the top circle outward to the edge, labeled. R another arrow beside the image going from top to bottom, labeled. H figure 3 right circular cylinder solution, evaluate the expression 2 letter 1d70b letter 1d45f. Letter 1d45f plus letter 210e, for letter 1d45f equals 6 and letter 210e equals 9. Letter 1d446 equals 2 letter 1d70b letter 1d45f. Letter 1d45f plus letter 210e 2 letter 1d70b. 6. 6 plus 9 2 letter 1d70b. 6. 15 180 letter 1d70b. The surface area is 180 letter 1d70b square inches. Try it 11. A photograph with length L and width W is placed in a mat of width 8 centimeters, cm. The area of the mat in square centimeters, or cm2, is found to be letter 1d434 equals letter 1d43f plus 16, letter 1d44a plus 16, minus letter 1d43f letter 1d44a. See figure 4. Find the area of a mat for a photograph with length 32 cm and width 24 cm. An art frame with a piece of artwork in the center. The frame has a width of 8 centimeters. The artwork itself has a length of 32 centimeters and a width of 24 centimeters. Figure 4, simplifying algebraic expressions. Sometimes we can simplify an algebraic expression to make it easier to evaluate or to use in some other way. To do so, we use the properties of real numbers. We can use the same properties in formulas because they contain algebraic expressions. Example 12. Simplifying algebraic expressions. Simplify each algebraic expression. A 3 letter 1 d465 minus 2 letter 1 d466 plus letter 1 d465 minus 3 letter 1 d466 minus 7b2 letter 1 d45f minus 5. 3 minus letter 1 d45f plus 4c 4 letter 1 d461 minus 54 letter 1 d460 minus 23 letter 1 d461 plus 2 letter 1 d460 d 2 letter 1 d45a letter 1 d45b minus 5 letter 1 d45a plus 3 letter 1 d45a letter 1 d45b plus letter 1 d45b solution A. 3 letter 1 d465 minus 2 letter 1 d466 plus letter 1 d465 minus 3 letter 1 d466 minus 7 equals 3 letter 1 d465 plus letter 1 d465 minus 2 letter 1 d466 minus 3 letter 1 d466 minus 74 letter 1 d465 minus 5 letter 1 d466 minus 7 commutative property of addition. Simplify. B2 letter 1 d45f minus 5 3 minus letter 1 d45f plus 4 equals 2 letter 1 d45f minus 15 plus 5 letter 1 d45f plus 42 letter 1 d45f plus 5 letter 1 d45f minus 15 plus 47 letter 1 d45f minus 11 distributive property. Commutative property of addition. Simplify. C. 4 letter 1 d461 minus 54 letter 1 d460 minus 23 letter 1 d461 plus 2 letter 1 d460 equals 4 letter 1 d461 minus 54 letter 1 d460 minus 23 letter 1 d461 minus 2 letter 1 d460 4 letter 1 d461 minus 23 letter 1 d461 minus 54 letter 1 d460 minus 2 letter 1 d4. Property. Commutative property of addition. Simplify. D2 letter 1 d45a letter 1 d45b minus 5 letter 1 d45a plus 3 letter 1 d45a letter 1 d45b plus letter 1 d45b equals 2 letter 1 d45a letter 1 d45b plus 3 letter 1 d45a letter 1 d45b minus 5 letter 1 d45a plus letter 1 d45b 5 letter 1 d45a letter 1 d45b minus 5 letter 1 d45a plus letter 1 d45b commutative. Property of addition. Simplify. Try at 12. Simplify each algebraic expression. A 23 letter 1 d466 minus 2, 43 letter 1 d466 plus letter 1 d467. B 5 letter 1 d461 minus 2 minus 3 letter 1 d461 plus 1 c4 letter 1 d45d. Letter 1 d45e minus 1 plus letter 1 d45e. 1 minus letter 1 d45d. D. 9 letter 1 d45f minus letter 1 d460 plus 2 letter 1 d45f plus 6 minus letter 1 d460. Example 13. Simplifying a formula A rectangle with length L and width W has a perimeter P given by letter 1 d443 equals letter 1 d43f plus letter 1 d44a plus letter 1 d43f plus letter 1 d44a. Simplify this expression. Solution letter 1 d443 letter 1 d443 letter 1 d443 letter 1 d443 equals letter 1 d43f plus letter 1 d44a plus letter 1 d43f plus letter 1 d44 letter 1 d43f plus letter 1 d43f plus letter 1 d44a plus letter 1 d448 letter 1 d43f plus 2 letter 1 d44a 2 letter 1 d43f plus letter 1 d44a. Commutative property of addition. Simplify distributive property. Try at 13. If the amount P is deposited into an account paying simple interest R for time T, the total value of the deposit A is given by letter 1 d434 equals letter 1 d443 plus letter 1 d443 letter 1 d45f letter 1 d461. Simplify the expression. This formula will be explored in more detail later in the course. Media access these online resources for additional instruction and practice with real numbers. Simplify an expression. Evaluate an expression 1. Evaluate an expression 2. 1 section exercises verbal 1. Is 2 square an example of a rational terminating, rational repeating, or irrational number? Tell why it fits that category. 2. What is the order of operations? What acronym is used to describe the order of operations, and what does it stand for? 3. What do the associative properties allow us to do when following the order of operations? Explain your answer. Numeric for the following exercises, simplify the given expression. For 10 plus 2 times, 5 minus 3, 5. 6 divided by 2 minus 81 divided by 32, 6. 18 plus 6 minus 8, 3, 7. Minus 2 times 16 divided by 8 minus 4, 2, 2, 8. 4 minus 6 plus 2 times 7, 9. 3, 5 minus 8, 10. 4 plus 6 minus 10 divided by 2, 11. 12 divided by 36 divided by 9 plus 6, 12. 4 plus 5, 2 divided by 3, 13. 3 minus 12 times 2 plus 19, 14. 2 plus 8 times 7 divided by 4, 15. 5 plus 6 plus 4 minus 11, 16. 9 minus 18 divided by 32, 17. 14 times 3 divided by 7 minus 6, 18. 9 minus 3 plus 11 times 2, 19. 6 plus 2 times 2 minus 1, 20. 64 divided by 8 plus 4 times 2, 21. 9 plus 4, 22, 22. 12 divided by 3 times 3, 2, 23. 25 divided by 52 minus 7, 24. 15 minus 7 times 3 minus 7, 25. 2 times 4 minus 9, minus 1, 26. 42 minus 25 times 15, 27. 12, 3 minus 1 divided by 6. Algebraic for the following exercises, evaluate the expression using the given value of the variable. 28. 8. Letter 1d465 plus 3, 64 for letter 1d465 equals 229. 4 letter 1d466 plus 8 2 letter 1d466 for letter 1d466 equals 330. 11 letter 1d44e plus 3 minus 18 letter 1d44e plus 4 for letter 1d44e equals 231. 4 letter 1d467 minus 2 letter 1d467. 1 plus 4, 36, for letter 1d467 equals 532. 4 letter 1d466. 7 minus 2, 2 plus 200 for letter 1d466 equals 233. Minus 2 letter 1d465, 2 plus 1 plus 3 for letter 1d465 equals 234. 8, 2 plus 4, minus 15 letter 1d44f plus letter 1d44f for letter 1d44f equals 335. 2, 11 letter 1d450 minus 4, 36 for letter 1d450 equals 036. 4, 3 minus 1, letter 1d465 4 for letter 1d465 equals 1037. 14, 8 letter 1d464 minus 42 for letter 1d464 equals 1 for the following exercises, simplify the expression. 38. 4 letter 1d465 plus letter 1d465, 13 minus 7, 39. 2 letter 1d466 minus, 4 2 letter 1d466 minus 1140. Letter 1d44e, 23, 64, minus 12 letter 1d44e divided by 641. 8 letter 1d44f minus 4 letter 1d44f, 3, plus 142. 5 letter 1d459 divided by 3 letter 1d459 times 9 minus 6, 43. 7 letter 1d467 minus 3 plus letter 1d467 times 6244. 4 times 3 plus 18 letter 1d465 divided by 9 minus 1245. 9 letter 1d466 plus 8 minus 2746. 96 letter 1d461 minus 4247. 6 plus 12 letter 1d44f minus 3 times 6 letter 1d44f 48. 18 letter 1d466 minus 2, 1 plus 7 letter 1d466, 49. 49 2 times 27 letter 1d465 50. 8 3 minus letter 1d45a plus 1 minus 8 51. 9 letter 1d465 plus 4 letter 1d465. 2 plus 3 minus 4, 2 letter 1d465 plus 3 letter 1d465, 52. 52 minus 4, 3 letter 1d465, real-world applications for the following exercises, consider this scenario. Fred earns $40 at the community garden. He spends $10 on a streaming subscription, puts half of what is left in a savings account, and gets another $5 for walking his neighbor's dog. 53. Write the expression that represents the number of dollars Fred keeps and does not put in his savings account. Remember the order of operations. 54. How much money does Fred keep? For the following exercises, solve the given problem. 55. According to the U.S. Mint, the diameter of a quarter is 0.955 inches. The circumference of the quarter would be the diameter multiplied by letter 1D70B. Is the circumference of a quarter a whole number, a rational number, or an irrational number? 56. Jessica and her roommate, Adriana, have decided to share a change jar for joint expenses. Jessica put her loose change in the jar first, and then Adriana put her change in the jar. We know that it does not matter in which order the change was added to the jar. What property of addition describes this fact? For the following exercises, consider this scenario. There is a mound of G pounds of gravel in a quarry. Throughout the day, 400 pounds of gravel is added to the mound. 2 orders of 600 pounds are sold, and the gravel is removed from the mound. At the end of the day, the mound has 1,200 pounds of gravel. 57. Write the equation that describes the situation. 58. Solve for G for the following exercise, solve the given problem. 59. Ramon runs the marketing department at their company. Their department gets a budget every year, and every year, they must spend the entire budget without going over. If they spend less than the budget, then the department gets a smaller budget the following year. At the beginning of this year, Ramon got $2.5 million for the annual marketing budget. They must spend the budget such that 2,500,000 minus letter 1D465 equals 0. What property of addition tells us what the value of x must be? Technology for the following exercises, use a graphing calculator to solve for x. Round the answers to the nearest hundredth. 60, 0, 5, 12, 3, 2 minus 48 letter 1D465 equals 3561. 0, 25 minus 0. 75 2 letter 1D465 minus 7. 2 equals 9. 9 extensions 62. If a whole number is not a natural number, what must the number be? 63. Determine whether the statement is true or false. The multiplicative inverse of a rational number is also rational. 64. Determine whether the statement is true or false. The product of a rational and irrational number is always irrational. 65. Determine whether the simplified expression is rational or irrational. Minus 18 minus 4, 5, minus 1 square. 66. Determine whether the simplified expression is rational or irrational. Minus 16 plus 4, 5, plus 5 square. 67. The division of two natural numbers will always result in what type of number? 68. What property of real numbers would simplify the following expression? 4 plus 7, letter 1D465 minus 1? Learning objectives in this section, you will use the product rule of exponents, use the quotient rule of exponents, use the power rule of exponents, use the zero exponent rule of exponents, use the negative rule of exponents. Find the power of a product and a quotient. Simplify exponential expressions. Use scientific notation. Mathematicians, scientists, and economists commonly encounter very large and very small numbers, but it may not be obvious how common such figures are in everyday life. For instance, a pixel is the smallest unit of light that can be perceived and recorded by a digital camera. A particular camera might record an image that is 2,048 pixels by 1,536 pixels, which is a very high-resolution picture. It can also perceive a color depth, gradations in colors, of up to 48 bits per pixel, and can shoot the equivalent of 24 frames per second. The maximum possible number of bits of information used to film a 1-hour, 3,600-second digital film is then an extremely large number. Using a calculator, we enter 2,048 times 1, 536 times 48 times 24 times 3, 600 and press enter. The calculator displays 304,596,316 E13. What does this mean? The E13 portion of the result represents the exponent 13 of 10, so there are a maximum of approximately 3 times 1,013 bits of data in that 1-hour film. In this section, we review rules of exponents first and then apply them to calculations involving very large or small numbers. Using the product rule of exponents, consider the product letter 1d465 3 letter 1d465 4. Both terms have the same base, x, but they are raised to different exponents. Expand each expression, and then rewrite the resulting expression. Letter 1d465 3 letter 1d465 4 equals letter 1d465 letter 1d465 letter 1d465 3 factors letter 1d465 letter 1d465 letter 1d465 letter 1d465 4f a ct ors letter 1d465 letter 1d465 letter 1d465 letter 1d465 letter 1d465 letter 1d465 letter 1d465. The result is that letter 1d465 3 letter 1d465 4 equals letter 1d465 3 plus 4 equals letter 1d465 7. Notice that the exponent of the product is the sum of the exponents of the terms. In other words, when multiplying exponential expressions with the same base, we write the result with the common base and add the exponents. This is the product rule of exponents. Letter 1d44 letter 1d45a, letter 1d44 letter 1d45b equals letter 1d44 letter 1d45a plus letter 1d45b. Now consider an example with real numbers. 23 24 equals 23 plus 4 equals 27. We can always check that this is true by simplifying each exponential expression. We find that 23 is 8, 24 is 16, and 27 is 128. The product 8 16 equals 128, so the relationship is true. We can use the product rule of exponents to simplify expressions that are a product of two numbers or expressions with the same base but different exponents. The product rule of exponents for any real number a and natural numbers m and n. The product rule of exponents states that letter 1d44 letter 1d45a, letter 1d44 letter 1d45b equals letter 1d44 letter 1d45a plus letter 1d45b. Example 1. Using the product rule, write each of the following products with a single base. Do not simplify further. A letter 1d461 5 letter 1d461 3b minus 3 5 minus 3. C letter 1d465 2 letter 1d465 5 letter 1d465 3. Solution. Use the product rule to simplify each expression. A letter 1d461 5 letter 1d461 3 equals letter 1d461 5 plus 3 equals letter 1d461 8b minus 3 5 minus 3 equals minus 3 5 minus 3 1 equals minus 3 5 plus 1 equals minus 3 6. C letter 1d465 2 letter 1d465 5 letter 1d465 3. At first, it may appear that we cannot simplify a product of three factors. However, using the associative property of multiplication, begin by simplifying the first two. Letter 1d465 2 letter 1d465 5 letter 1d465 3 equals letter 1d465 2 letter 1d465 5 letter 1d465 3 equals letter 1d465 2 plus 5 letter 1d465 3 equals letter 1d465 7 letter 1d465 3 equals letter 1d465 7 plus 3 equals letter 1d465 10. Notice we get the same result by adding the three exponents. One step. Letter 1d465 2 letter 1d465 5 letter 1d465 3 equals letter 1d465 2 plus 5 plus 3 equals letter 1d465 10. Try it 1. Write each of the following products with a single base. Do not simplify further. A letter 1d458 6 letter 1d458 9b 2 letter 1d466 4 2 letter 1d466. C letter 1d461 3 letter 1d461 6 letter 1d461 5. Using the quotient rule of exponents, the quotient rule of exponents allows us to simplify an expression that divides two numbers with the same base but different exponents. In a similar way to the product rule, we can simplify an expression such as letter 1d466 letter 1d45a letter 1d466 letter 1d45b, where letter 1d45a, letter 1d45b. Consider the example. Perform the division by canceling common factors. Letter 1d466 9 letter 1d466 5 equals letter 1d466 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 letter 1 D466, letter 1 D466, letter 1 D466, letter 1 D466, letter 1 D466 let. Notice that the exponent of the quotient is the difference between the exponents of the divisor and dividend. Letter 1 D44, letter 1 D45A, letter 1 D44E, letter 1 D45B equals letter 1 D44E, letter 1 D45A minus letter 1 D45B. In other words, when dividing exponential expressions with the same base, we write the result with the common base and subtract the exponents. Letter 1 D466 9, letter 1 D466, 5 equals letter 1 D466, 9 minus 5 equals letter 1 D466, 4, for the time being. We must be aware of the condition letter 1 D45A, letter 1 D45B. Otherwise, the difference letter 1 D45A minus letter 1 D45B could be 0 or negative. Those possibilities will be explored shortly. Also, instead of qualifying variables as non-zero each time, we will simplify matters and assume from here on that all variables represent non-zero real numbers. The quotient rule of exponents for any real number a and natural numbers m and n, such that letter 1 D45A, letter 1 D45B. The quotient rule of exponents states that letter 1 D44, letter 1 D45A, letter 1 D44E, letter 1 D45B equals letter 1 D44, letter 1 D45A minus letter 1 D45B. Example 2, using the quotient rule, write each of the following products with a single base. Do not simplify further. A minus 2 14, minus 2 9 bt 23 t 15 c, letter 1 D467 2 square root, 5 letter 1 D467 2 square root solution, use the quotient rule to simplify each expression. A minus 2, 14, minus 2 9 equals minus 2, 14 minus 9 equals minus 2, 5b letter 1 D461 23 letter 1 D461 15 equals letter 1 D461, 23 minus 15 equals letter 1 D461 8c, letter 1 D467 2 square root, 5 letter 1 D467 2 square equals, letter 1 D467 2 square 5 minus 1 equals, letter 1 D467 2 square 4 try it 2. Write each of the following products with a single base. Do not simplify further. AS75 68B minus 3, 6 minus 3c, letter 1 D45 to letter 1 D453 2 5, letter 1 D45 to letter 1 D453 2 3. Using the power rule of exponents, suppose an exponential expression is raised to some power. Can we simplify the result? Yes. To do this, we use the power rule of exponents. Consider the expression letter 1 D46523. The expression inside the parentheses is multiplied twice because it has an exponent of 2. Then the result is multiplied 3 times because the entire expression has an exponent of 3. Factors, the exponent of the answer is the product of the exponents. Letter 1 D4652, 3 equals letter 1 D4652, 3 equals letter 1 D4656. In other words, when raising an exponential expression to a power, we write the result with the common base and the product of the exponents. Letter 1 D44, letter 1 D45A. Letter 1 D45B equals letter 1 D44, letter 1 D45A, letter 1 D45B. Be careful to distinguish between uses of the product rule and the power rule. When using the product rule, different terms with the same bases are raised to exponents. In this case, you add the exponents. When using the power rule, a term in exponential notation is raised to a power. In this case, you multiply the exponents. 53 54 letter 1 D465 5 letter 1 D465 2 3 letter 1 D44E 7 3 letter 1 D44E 10 equals product. Rule 53 plus 4 letter 1 D465 5 plus 2 3 letter 1 D44E 7 plus 10 equals 57 letter 1 D465 7 3 letter 1 D44E 17 but 53 4 letter 1 D465 5 2 3 letter 1 D44E 7 10 power. Rule equals 53 4 letter 1 D465 5 2 3 letter 1 D44E 7 10 equals 512 letter 1 D465 10 3 letter 1 D44E 70. The power rule of exponents for any real number a and positive integers m and n. The power rule of exponents states that letter 1 D44, letter 1 D45A, letter 1 D45B equals letter 1d44, letter 1d45a, letter 1d45b, example 3. Using the power rule, write each of the following products with a single base. Do not simplify further. A. Letter 1d4652, 7b, 2 letter 1d461, 5, 3c, minus 3, 5, 11 solution. Use the power rule to simplify each expression. A. Letter 1d4652, 7 equals letter 1d4652, 7 equals letter 1d465, 14b, 2 letter 1d461, 5, 3 equals 2 letter 1d461, 5, 3 equals 2 letter 1d461, 15c. Try it 3. Write each of the following products with a single base. Do not simplify further. A. 3 letter 1d466, 8, 3b, letter 1d461, 5, 7c, minus letter 1d454, 4, 4. Using the zero exponent rule of exponents, return to the quotient rule. We made the condition that letter 1d45a, letter 1d45b, so that the difference letter 1d45a minus letter 1d45b would never be 0 or negative. What would happen if letter 1d45a equals letter 1d45b? In this case, we would use the zero exponent rule of exponents to simplify the expression to 1. To see how this is done, let us begin with an example. If we were to simplify the original expression using the quotient rule, we would have a. If we equate the two answers, the result is letter 1d4610 equals 1. This is true for any non-zero real number or any variable representing a real number. Letter 1d44e0 equals 1. The sole exception is the expression. This appears later in more advanced courses, but for now, we will consider the value to be undefined. The zero exponent rule of exponents for any non-zero real number a. The zero exponent rule of exponents states that letter 1d44e0 equals 1. Example 4. Using the zero exponent rule, simplify each expression using the zero exponent rule of exponents. A, b minus 3 letter 1d465, 5 letter 1d465, 5c, j to letter 1d458, 4. Letter 1d457 to letter 1d458. Letter 1d457 to letter 1d458's 3d5. Letter 1d45f letter 1d460, 2, 2. Letter 1d45f letter 1d460, 2, 2 solution. Use the zero exponent and other rules to simplify each expression. A letter 1d450, 3 letter 1d450, 3 equals letter 1d450, 3 minus 3 letter 1d450, 0, 1b minus 3 letter 1d465, 5 letter 1d465, 5 equals minus 3 letter 1d465, 5 letter 1d465, 5 minus 3 letter 1d465, 5 minus 5 minus 3 letter 1d465, 0 minus 3 1 minus 3c, jeta. Letter 1d4584, letter 1d457 to letter 1d458. Letter 1d457 to letter 1d458's 3 equals. Letter 1d457 to letter 1d458, 4 letter 1d457 to letter 1d458. 1 plus 3. Letter 1d457 to letter 1d458, 4 letter 1d457 to letter 1d458, 4. Letter 1d457 to letter 1d458, 4 minus 4. Letter 1d457 to letter 1d458. 0, 1. Use the product rule in the denominator. Simplify. Use the quotient rule. Simplify. D5, letter 1d45f letter 1d460, 2, 2. Letter 1d45f letter 1d460, 2, 2 equals 5 letter 1d45f letter 1d460, 2, 2 minus 25. Letter 1d45f letter 1d460, 2, 0, 5, 15. Use the quotient rule. Simplify. Use the zero exponent rule. Simplify. Try it 4. Simplify each expression using the zero exponent rule of exponents. A, b, letter 1d451, letter 1d452, 2, 112. Letter 1d451, letter 1d452, 211, c, d, letter 1d461, 3, letter 1d461, 4, letter 1d461, 2, letter 1d461, 5. Using the negative rule of exponents, another useful result occurs if we relax the condition that letter 1d45a, letter 1d45b in the quotient rule even further. For example, can we simplify when letter 1d45a, letter 1d45b? That is, where the difference letter 1d45a minus letter 1d45b is negative. We can use the negative rule of exponents to simplify the expression to its reciprocal. Divide one exponential expression by another with a larger exponent. Use our example, h3h5. 210e, 3 letter 210e. 5 equals letter 210e, letter 210e. Letter 210e, letter 210e, letter 210e. Letter 210e, letter 210e, letter 210e, letter 210e. Letter 210e, letter 210e, letter 210e. Letter 210e, letter 210e, letter 210e, letter 210e. 1 letter 210e, letter 210e. 1 letter 210e, 2. If we were to simplify the original expression using the quotient rule, we would have letter 210e, 3 letter 210e, 5 equals letter 210e, 3 minus 5 letter 210e minus 2, putting the answers together. We have letter 210e minus 2 equals 1 letter 210e 2. This is true for any non-zero real number, or any variable representing a non-zero real number. A factor with a negative exponent becomes the same factor with a positive exponent if it is moved across the fraction bar, from numerator to denominator or vice versa. Letter 1d44e minus letter 1d45b equals 1 letter 1d44e letter 1d45b, a n d letter 1d44e letter 1d45b equals 1 letter 1d44e minus letter 1d45b. We have shown that the exponential expression n is defined when n is a natural number. 0, or the negative of a natural number. That means that n is defined for any integer n also. The product and quotient rules, and all of the rules we will look at soon hold for any integer n. The negative rule of exponents for any non-zero real number a and natural number n. The negative rule of exponents states that letter 1d44e minus letter 1d45b equals 1 letter 1d44e letter 1d45b example 5. Using the negative exponent rule, write each of the following quotients with a single base. Do not simplify further. Write answers with positive exponents. A letter 1d703, 3 letter 1d703, 10 b letter 1d467, 2 letter 1d467 letter 1d467 4c, minus 5 letter 1d461 4. Minus 5 letter 1d461 8 solution A. Letter 1d703, 3 letter 1d703, 10 equals letter 1d703, 3 minus 10 equals letter 1d703, minus 7 equals 1 letter 1d703, 7b. Letter 1d467, 2 letter 1d467 letter 1d467, 4 equals letter 1d467, 2, plus 1 letter 1d467, 4 equals letter 1d467, 3, letter 1d467, 4 equals letter 1d467, 3 minus 4 equals letter 1d467 minus 1 equals 1 letter 1d467c. Minus 5 letter 1d461 4, minus 5 letter 1d461 8 equals, minus 5 letter 1d461 4 minus 8 equals, minus 5 letter 1d461 minus 4 equals 1, minus 5 letter 1d461 4 try it 5 write each of the following quotients with a single base. Do not simplify further. Write answers with positive exponents. A minus 3 letter 1d461 2. Minus 3 letter 1d461. 8b letter 1d453 47 letter 1d453 49 letter 1d453 C2 K45 K7 example 6. Using the product and quotient rules, write each of the following products with a single base. Do not simplify further. Write answers with positive exponents. A letter 1d44f, 2 letter 1d44f minus 8b, minus letter 1d465, 5, minus letter 1d465, minus 5c minus 7 letter 1d467, minus 7 letter 1d467. 5 solution A letter 1d44f, 2 letter 1d44f, minus 8 equals letter 1d44f, 2 minus 8 equals letter 1d44f, minus 6 equals 1 letter 1d44f, 6b. Minus letter 1d465, 5, minus letter 1d465, minus 5 equals, minus letter 1d465, 5 minus 5 equals, minus letter 1d465 0 equals 1c. Minus 7 letter 1d467, minus 7 letter 1d467 5 equals, minus 7 letter 1d467. 1 minus 7 letter 1d467, 5 equals, minus 7 letter 1d467, 1 minus 5 equals, minus 7 letter 1 d4 6 7, minus 4 equals 1, minus 7 letter 1 d4 6 7. 4. Try it. 6. Write each of the following products with a single base. Do not simplify further. Write answers with positive exponents. A. Letter 1 d4 6 1 minus 11 letter 1 d4 6 1, 6b, 25,122,513. Finding the power of a product. To simplify the power of a product of two exponential expressions, we can use the power of a product rule of exponents, which breaks up the power of a product of factors into the product of the powers of the factors. For instance, consider letter 1d4 5d letter 1d4 5e 3. We begin by using the associative and commutative properties of multiplication to regroup the factors. Letter 1d4 5d letter 1d4 5e 3 equals. Letter 1d4 5d letter 1d4 5e. Letter 1d4 5d letter 1d4 5e. Letter 1d4 5d letter 1d4 5e 3. F a c t o r s letter 1d4 5d. Letter 1d4 5e. Letter 1d4 5d. Letter 1d4 5e. Letter 1d4 5d. Letter 1d4 5e. Letter 1d4 5d. Letter 1d4 5d. Letter 1d4 5d. 3 factors letter 1d4 5e. In other words, letter 1d4 5d letter 1d4 5e 3 equals letter 1d4 5d. 3 letter 1d4 5e 3. The power of a product rule of exponents for any real numbers a and b and any integer n. The power of a product rule of exponents states that letter 1d4 4e letter 1d4 4f. Letter 1d4 5b equals letter 1d4 4e letter 1d4 5b letter 1d4 4f letter 1d4 5b. Example 7. Using the power of a product rule, simplify each of the following products as much as possible using the power of a product rule. Write answers with positive exponents. A. Letter 1d4 4e letter 1d4 4f 2, 3b 2 letter 1d4 6 1. 15c, minus 2 letter 1d4 6 4 3, 3d1, minus 7 letter 1d4 6 7. 4e letter 1d4 5 2 minus 2 letter 1d4 5 3 2. 7. Solution. Use the product and quotient rules and the new definitions to simplify each expression. A. Letter 1d4 4e letter 1d4 4f 2 3 equals letter 1d4 4e 3. Letter 1d4 4f 2 3 equals letter 1d4 4e 1 3 letter 1d4 4f 2 3 equals letter 1d4 4e 3 letter 1d4 4f 6b 2 letter 1d4 6 1. 15 equals 2 15. Letter 1d4 6 1 15 equals 215 letter 1d4 6 1 15 equals 32. 768 T15C minus 2 letter 1d4 6 4 3 3 equals minus 2 3. Letter 1d4 6 4 3 3 equals minus 8 letter 1d4 6 4 3 3 equals minus 8 letter 1d4 6 4 9 d1 minus 7 letter 1d4 6 7 4 equals 1 minus 7 4 letter 1d4 6 7 4 equals 12. 401 z4 e letter 1d4 5 2 minus 2 letter 1d4 5 3 2 7 equals letter 1d4 5 2 minus 2 7 letter 1d4 5 3 2 7 equals letter 1d4 5 2 minus 2 7 letter 1d4 5 3 2 7 equals letter 1d4 5 2 minus 14 letter 1d4 5 3 14 equals letter 1d4 5 3 14 letter 1d4 5 2 14. Try it. 7. Simplify each of the following products as much as possible using the power of a product rule. Write answers with positive exponents. A. G to letter 210 e 3 5b 5 letter 1d4 6 1 3c minus 3 letter 1d4 6 6 5 3d1 letter 1d4 4e 6 letter 1d4 4f 7 3e letter 1d4 5f 3 letter 1d4 6 0 minus 2 4. Finding the power of a quotient. To simplify the power of a quotient of two expressions, we can use the power of a quotient rule, which states that the power of a quotient of factors is the quotient of the powers of the factors. For example, let's look at the following example. Letter 1 d4 5 2 minus 2 letter 1 d4 5 3 2 7 equals letter 1 d4 5 3 14 letter 1 d4 5 2 14. Let's rewrite the original problem differently and look at the result. Letter 1 d4 5 2 minus 2 letter 1 d4 5 3 2 7 equals letter 1 d4 5 3 to letter 1 d4 5 2 2 7 letter 1 d4 5 3 14 letter 1 d4 5 2 14. It appears from the last two steps that we can use the power of a product rule as a power of a quotient rule. Letter 1 d4 5 2 minus 2 letter 1 d4 5 3 2 7 equals Letter 1 D453 to letter 1 D4522. 7. Letter 1 D45327. Letter 1 D4522. 7. Letter 1 D4532. 7. Letter 1 D4522. 7. Letter 1 D453. 14. Letter 1 D452. 14. The power of a quotient rule of exponents for any real numbers a and b and any integer n. The power of a quotient rule of exponents states that letter 1 D44 letter 1 D44f. Letter 1 D45b equals letter 1 D44 letter 1 D45b letter 1 D44f letter 1 D45b. Example, 8. Using the power of a quotient rule, simplify each of the following quotients as much as possible using the power of a quotient rule. Write answers with positive exponents. A. 4 letter 1 D467, 11 3b, letter 1 D45 to letter 1 D45e3. 6c. -1 letter 1 D4612, 27d. Letter 1 D457 3 letter 1 D458 -2, 4e letter 1 D45a -2 letter 1 D45b -2, 3 solution A. 4 letter 1 D467 11 3 equals 4 3. Letter 1 D467 11 3 equals 64 letter 1 D467 11 3 equals 64 letter 1 D467 33b. Letter 1 D45 to letter 1 D45e3 6 equals letter 1 D45d. 6. Letter 1 D45e3. 6 equals letter 1 D45d. 1 6 letter 1 D45e. 3 6 equals letter 1 D45d. 6 letter 1 D45e. 18c. -1 letter 1 D461 227 equals -1 27. Letter 1 D461 227 equals -1 letter 1 D461 227 equals -1 letter 1 D461 54 equals -1 letter 1 D461 54d. Letter 1 D457 3 letter 1 D458 -2 4 equals. Letter 1 D457 3 letter 1 D458 2 4 equals. Letter 1 D457 3 4. Letter 1 D458 2 4 equals letter 1 D457 3 4 letter 1 D458 2 4 equals letter 1 D457 12 letter 1 D458 8e. Letter 1 D45a -2 letter 1 D45b -2 3 equals 1 letter 1 D45a2. Letter 1 D45b2 3 equals 1 3. Letter 1 D458 letter 1 D45b2 3 equals 1. Letter 1 D45a2 3. Letter 1 D45b2 3 equals 1 letter 1 D45a2 3 letter 1 D45b2 3 equals 1 letter 1 D45a 6 letter 1 D45b 6. Try it. 8. Simplify each of the following quotients as much as possible using the power of a quotient rule. Write answers with positive exponents. A. Letter 1 D44f, 5 letter 1 D450, 3b, 5 letter 1 D4628, 4c, -1 letter 1 D4643, 35d, letter 1 D45d -4 letter 1 D45e3 8, e letter 1 D450, -5 letter 1 D451 -3. 4. Simplifying exponential expressions. Recall that to simplify an expression means to rewrite it by combining terms or exponents. In other words, to write the expression more simply with fewer terms. The rules for exponents may be combined to simplify expressions. Example 9. Simplifying exponential expressions. Simplify each expression and write the answer with positive exponents only. A. 6 m to letter 1 D45b, -1 3b 175 17, -4 17 -3c. Letter 1 D462, -1 letter 1 D463 letter 1 D463, -1 2d, -2 letter 1 D440, 3 letter 1 D44f -1. 5 letter 1 D440 -2 letter 1 D44f 2. E. Letter 1 D465 22 square 4. Letter 1 D465 22 square -4f 3 letter 1 D464 2. 5, 6 letter 1 D464 -2, 2 solution A 6 empta. Letter 1 D45b -1 3 equals 6 3. Letter 1 D45a 2 3. Letter 1 D45b -1 363 letter 1 D45a 2 3 letter 1 D45b -1 3216 letter 1 D45a 6 letter 1 D45b -3216 letter 1 D45a 6 letter 1 D45b 3. The power of a product rule. The power rule. Simplify. The negative exponent rule. B 175 17 -4 17 -3 equals 175 -4 -317 minus 21,172, or 1289, the product rule simplify. The negative exponent rule C. Letter 1d462, minus 1 letter 1d463 letter 1d463, minus 1 2 equals. Letter 1d462, minus 1 letter 1d463 2 letter 1d463, minus 1 2 letter 1d462, minus 2 letter 1d463 ta. Letter 1d463, minus 2 letter 1d462, minus 2 letter 1d463, 2 minus. Minus 2 letter 1d462, minus 2 letter 1d463, 4 letter 1d463, 4 letter 1d462 to the power, of a quotient rule the power, of a product rule the quotient rule simplify. The negative exponent rule D. Minus 2 letter 1d440, 3 letter 1d44f minus 1. 5 letter 1d44e minus 2 letter 1d44f, 2 equals minus, 2 5 letter 1d44e 3 letter 1d44e minus 2 letter 1d44f, minus 1 letter 1d44f, 2 minus 10 letter 1d44e 3, minus 2 letter 1d44f, minus 1 plus 2 minus 10, letter 1d44 letter 1d44f, commutative and associative laws of multiplication. The product rule simplify. E. Letter 1d465 22 square 4. Letter 1d465 22 square minus 4 equals. Letter 1d465 22 square 4 minus 4. Letter 1d465 22 square 0, 1. The product rule simplify. The zero exponent rule F. 3 letter 1d464 2, 5. 6 letter 1d464 minus 2 2 equals. 3 5. Letter 1d464 2, 5, 6 2. Letter 1d464 minus 2 235. Letter 1d464 2 562. Letter 1d464 minus 2 2243. Letter 1d464 1036. Letter 1d464 minus 427. Letter 1d464 10. Power of a product rule the power rule simplify. The quotient rule and reduce fraction simplify. Try at 9 simplify each expression and write the answer with positive exponents only. A. 2 letter 1d462 letter 1d463, minus 2 minus 3b letter 1d465, 8 letter 1d465, minus 12 letter 1d465 C. E to letter 1d453, minus 3 letter 1d453, minus 1 2d, 9 letter 1d45f, minus 5 letter 1d4603. 3 letter 1d45f, 6 letter 1d460 minus 4, E. 49 letter 1d461 letter 1d464 minus 2, minus 3, 49 letter 1d461 letter 1d464 minus 2, 3 F, 2 H to letter 1d4584. 7 letter 210 E minus 1 letter 1d45822. Using scientific notation recall at the beginning of the section that we found the number 1. 3 times 1013 when describing bits of information in digital images. Other extreme numbers include the width of a human hair, which is about 0. 5 m, and the radius of an electron, which is about 0. 47 m. How can we effectively work, read, compare, and calculate with numbers such as these? A shorthand method of writing very small and very large numbers is called scientific notation, in which we express numbers in terms of exponents of 10. To write a number in scientific notation, move the decimal point to the right of the first digit in the number. Write the digits as a decimal number between 1 and 10. Count the number of places n that you moved the decimal point. Multiply the decimal number by 10 raised to a power of n. If you move the decimal left as in a very large number, n is positive. If you move the decimal right as in a very small number, n is negative. For example, consider the number 2,780,418. Move the decimal left until it is to the right of the first non-zero digit, which is 2. The number 2,780,418 is written with an arrow extending to another number. 2,780,418. An arrow tracking the movement of the decimal point runs underneath the number. Above the number, a label on the number reads, 6 places left. We obtain 2,780,418 by moving the decimal point 6 places to the left. Therefore, the exponent of 10 is 6, and it is positive because we moved the decimal point to the left. This is what we should expect for a large number. 2,780,418 times 106 working with small numbers is similar. Take, for example, the radius of an electron, 0. 47m perform the same series of steps as above, except move the decimal point to the right. The number 0, 47, is written with an arrow extending to another number, 4. 7, an arrow tracking the movement of the decimal point runs underneath the number. Above the number, a label on the number reads, 13 places right. Be careful not to include the leading 0 in your count. We move the decimal point 13 places to the right, so the exponent of 10 is 13. The exponent is negative because we moved the decimal point to the right. This is what we should expect for a small number. 4. 7 times 10 minus 13, scientific notation. A number is written in scientific notation if it is written in the form letter 1 d44e times 10 letter 1 d45b, where 1 less letter 1 d44e 10 and n is an integer. Example 10, converting standard notation to scientific notation, write each number in scientific notation. A distance to Andromeda Galaxy from Earth, 24 sextillion MB diameter of Andromeda Galaxy. 1 sextillion 300 quintillion MC, number of stars in Andromeda Galaxy. 1 trillion D diameter of electron. 0.94 ME, probability of being struck by lightning in any single year. 143 solution A24. 000, 000, 000, 000, 000, 000, 000, 000, 000, 000 M24. 0000000 M left arrow 22 places 2. 4 times 1022 MB1, 300, 000, 000, 000, 000, 000, 000, 000, 000 M1, 300, 000, 000, 000, 000, 000, 000, 000 M left arrow 21 places 1. 3 times 1021 MC1, 000, 000, 000, 000, 000, 00001, 000, 000, 000 left arrow 12 places 1 times 1012 D0. 94 M0, M places, 4 times 10 minus 13 M E0, 1430. 000, 000, 143 right arrow 6 places 1. 43 times 10 minus 6 analysis. Observe that, if the given number is greater than 1, as in examples A, C, the exponent of 10 is positive. And if the number is less than 1, as in examples D, E, the exponent is negative. Try it 10 write each number in scientific notation. A U.S. national debt per taxpayer, April 2014, $152,000 B world population, April 2014, 7,158,000,000 C world gross national income, April 2014, $85,500,000,000,000 D time for light to travel 1 M. 0,334 SE probability of winning lottery, match 6 of 49 possible numbers. 0. 715, converting from scientific to standard notation. To convert a number in scientific notation to standard notation, simply reverse the process. Move the decimal n places to the right if n is positive or n places to the left if n is negative, and add zeros as needed. Remember, if n is positive, the absolute value of the number is greater than 1. And if n is negative, the absolute value of the number is less than 1. Example 11, converting scientific notation to standard notation, convert each number in scientific notation to standard notation. A3. 540, 7 times 1014, B minus 2 times 106 C, 791 times 10 minus 7 D minus 8. 0, 5 times 10 minus 12. Solution A3 547 times 10,143. 54,700,000,000,000 right arrow 14 places 354, 700, 000, 000, 000, 000 B minus 2 times 106 minus 2. 000, 000, 000 right arrow 6 places minus 2, 000, 000, 000 C7. 91 times 10 minus 70,000,007. 91 left arrow 7 places 0. 791 d minus 8. 0. 5 times 10 minus 12 minus 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 8. 0. 5 left arrow 12 places minus 0. 805 try it 11 convert each number in scientific notation to standard notation. A7. 0 3 times 105 b minus 8. 16 times 1011 c minus 3. 9 times 10 minus 13 d 8 times 10 minus 6. Using scientific notation in applications scientific notation, used with the rules of exponents, makes calculating with large or small numbers much easier than doing so using standard notation. For example, suppose we are asked to calculate the number of atoms in 1 L of water. Each water molecule contains 3 atoms, 2 hydrogen, and 1 oxygen. The average drop of water contains around 1.32 times 1021 molecules of water, and 1 L of water holds about 1.22 times 104 average drops. Therefore, there are approximately 3.32 times 1021, 1.22 times 104, approximately 4.83 times 1025 atoms in 1 L of water. We simply multiply the decimal terms and add the exponents. Imagine having to perform the calculation without using scientific notation. When performing calculations with scientific notation, be sure to write the answer in proper scientific notation. For example, consider the product 7 times 104, 5 times 106 equals 35 times 1010. The answer is not in proper scientific notation because 35 is greater than 10. Consider 35 as 3, 5 times 10. That adds a 10 to the exponent of the answer. 35 times 1010 equals 3. 5 times 10 times 1010 equals 3. 5 times 10 times 1010 equals 3. 5 times 1011 example 12. Using scientific notation, perform the operations and write the answer in scientific notation. A8. 14 times 10 minus 7. 6. 5 times 1010 b. 4 times 105 divided by minus 1. 52 times 109 c. 2. 7 times 105, 6. D1, 2 times 108 divided by 9. 6 times 105, E3. 33 times 104, minus 1. 0, 5 times 107, 5. 62 times 105, solution A8. 14 times 10 minus 7, 6. 5 times 1010 equals 8. 14 times 6, 5. 10 minus 7 times 1010, 52. 91, 103, 5. 291 times 104 commutative and associative properties of multiplication product rule of exponent scientific notation, B. 4 times 100, 5 divided by minus 1. 52 times 109 equals approximately equals 4 minus 1. 52, 105,109 minus 2. 63, 10 minus 4 minus 2. 63 times 10 minus 4, commutative and associative properties of multiplication quotient rule of exponent scientific notation, C. 2, 7 times 105. 6. 0, 4 times 1013 equals 2. 7 times 6. 0, 4, 105 times 1013, 16. 308, 1018, 1. 6,308 times 1019, commutative and associative properties of multiplication product rule of exponent scientific notation D. 1. 2 times 108 divided by 9. 6 times 105 equals 1, 29. 6. 108,105, 0. 125, 103, 1. 25 times 102 commutative and associative properties of multiplication quotient rule of exponent scientific notation, E3. 33 times 104, minus 1. 0, 5 times 107, 5. 62 times 105 equals approximately equals 3. 33 times minus 1. 0, 5 times 5. 62, 104 times 107 times 105. Minus 19. 65, 1016, minus 1. 965 times 1017. Try it 12. Perform the operations and write the answer in scientific notation. A minus 7, 5 times 108, 1. 13 times 10 minus 2, B, 1. 24 times 1011 divided by 1. 55 times 1018, C, 3. 72 times 109, 8 times 103, D, 9. 933 times 1023 divided by minus 2. 31 times 1017, E, minus 6. 0, 4 times 109, 7. 3 times 102, minus 2. 81 times 102. Example 13, applying scientific notation to solve problems in April 2014. The population of the United States was about 308 million people. The national debt was about $17,547 billion. Write each number in scientific notation, rounding figures to 2 decimal places, and find the amount of the debt per U.S. citizen. Write the answer in both scientific and standard notations. Solution: the population was 308,000,000 equals 3. 08 times 108. The national debt was 17,547,000,000,000 approximately $1. 75 times 1013. To find the amount of debt per citizen, divide the national debt by the number of citizens. 1. 75 times 1013 divided by 3. 08 times 108 equals approximately equals 1. 753. 08, 1,013,180. 57 times 1,055. 7 times 104, the debt per citizen at the time was about $5. 7 times 104, or $57,000. Try it 13. An average human body contains around 30 trillion red blood cells. Each cell measures approximately 0.8 m long. Write each number in scientific notation and find the total length if the cells were laid end to end. Write the answer in both scientific and standard notations. Media access these online resources for additional instruction and practice with exponents and scientific notation. Exponential notation, properties of exponents: 0, exponent simplify, exponent expressions, quotient rule for exponents, scientific notation, converting to decimal notation, 1-2 section, exercises, verbal 1. Is 23 the same as 32? Explain. 2. When can you add 2 exponents? 3. What is the purpose of scientific notation? 4. Explain what a negative exponent does. Numeric for the following exercises, simplify the given expression. Write answers with positive exponents. 592 6, 15 minus 2 7, 32 times 33 8, 44 divided by 4 9, 22 minus 2 10, 5 minus 8 0 11, 113 divided by 114 12, 65 times 6 minus 7 13, 80 2 14. 5 minus 2 divided by 52. For the following exercises, write each expression with a single base. Do not simplify further. Write answers with positive exponents. 15. 42 times 43 divided by 4 minus 4 16. 61,269 17. 123 times 12 10 18. 106 divided by 1010 minus 2 19. 7 minus 6 times 7 minus 3 20. 33 divided by 34 5. For the following exercises, express the decimal in scientific notation. 21, 0 314 22. 148 million. For the following exercises, convert each number in scientific notation to standard notation. 23 1. 6 times 1010 24. 9 8 times 10 minus 9. Algebraic. For the following exercises, simplify the given expression. Write answers with positive exponents. 25. A3, A2A, 26. Letter 1D45A, letter 1D45 beta, letter 1D45A, minus 227. Letter 1D44F, 3, letter 1D450, 4, 228. Letter 1D465 minus 3, letter 1D4662, minus 529. Letter 1d44 letter 1d44f 2 divided by letter 1d451 minus 330. Letter 1d4640 letter 1d4655 5 minus 131. M4n0 32. Letter 1d466 minus 4, letter 1d4662 233. Letter 1d45d minus 4, letter 1d45e to p to letter 1d45e minus 334. Letter 1d459 times letter 1d464, 235. Letter 1d46673 divided by letter 1d465, 1436. Letter 1d44e, 23, 237. 25 letter 1d45a divided by 50 letter 1d45a, 38. 16 letter 1d465 square root 2 letter 1d466 minus 139. 23 3 letter 1d44e minus 240. Letter 1d45a letter 1d44e 6. 21 letter 1d45a 3 letter 1d44e 241. Letter 1d44f minus 3 letter 1d450 342. X to letter 1d466 13 divided by letter 1d4660 243. 9 letter 1d467 3 minus 2 letter 1d466 real-world applications 44. To reach escape velocity, a rocket must travel at the rate of 2 times 106 ft/min. Rewrite the rate in standard notation. 45. A dime is the thinnest coin in U.S. currency. A dime's thickness measures 1.35 times 10⁻³ m. Rewrite the number in standard notation. 46. The average distance between Earth and the Sun is 92,960,000 mi. Rewrite the distance using scientific notation. 47. A terabyte is made of approximately 1,099,500,000,000 bytes. Rewrite in scientific notation. 48. The gross domestic product, GDP, for the United States in the first quarter of 2014 was $1. 71,496 times 1,013. Rewrite the GDP in standard notation. 49. 1 picometer is approximately 397 times 10⁻11 in. Rewrite this length using standard notation. 50. The value of the services sector of the U.S. economy in the first quarter of 2012 was $10,633. $6 billion. Rewrite this amount in scientific notation. Technology for the following exercises: use a graphing calculator to simplify. Round the answers to the nearest hundredth. 51. 123 letter 1d45a 334 minus 3252. 173 divided by 152 letter 1d465 3 extensions for the following exercises. Simplify the given expression. Write answers with positive exponents. 53. 32 letter 1d44e 3 minus 2 letter 1d44e 422 to 54. 62 minus 24 2 divided by letter 1d465 letter 1d466 minus 555. M2n 3 8 letter 1d450 minus 3 letter 1d440 minus 7 letter 1d45b minus 2 letter 1d458 c 456. Letter 1d465 6 letter 1d466 3 letter 1d465 3 letter 1d466 minus 3 letter 1d466 minus 7 letter 1d465 minus 3 1057. Opt to letter 1d450 minus 3 letter 1d44f minus 3 258. Avogadro's constant is used to calculate the number of particles in a mole. A mole is a basic unit in chemistry to measure the amount of a substance. The constant is 6.0221413 times 1023. Write Avogadro's constant in standard notation. 59. Planck's constant is an important unit of measure in quantum physics. It describes the relationship between energy and frequency. The constant is written as 62,606,957 times 10⁻34. Write Planck's constant in standard notation. Learning objectives in this section, you will evaluate square roots. Use the product rule to simplify square roots. Use the quotient rule to simplify square roots. Add and subtract square roots. Rationalize denominators. Use rational roots. A hardware store sells 16 FT ladders and 24 FT ladders. A window is located 12 feet above the ground. A ladder needs to be purchased that will reach the window from a point on the ground 5 feet from the building. To find out the length of ladder needed, we can draw a right triangle as shown in Figure 1 and use the Pythagorean theorem. A right triangle with a base of 5 feet, a height of 12 feet, and a hypotenuse labeled C Figure 1 letter 1d44e, 2, plus letter 1d44f, 252, plus 122,169, equals letter 1d450 to C to say, 2 now. We need to find out the length that, when squared, is 169, to determine which ladder to choose. In other words, we need to find a square root. In this section, we will investigate methods of finding solutions to problems such as this one. Evaluating square roots. When the square root of a number is squared, the result is the original number. Since 42 equals 16, the square root of 16 is 4. The square root function is the inverse of the squaring function, just as subtraction is the inverse of addition. To undo squaring, we take the square root. In general terms, if a is a positive real number, then the square root of a is a number that, when multiplied by itself, gives. The square root could be positive or negative, because multiplying two negative numbers gives a positive number. The principal square root is the non-negative number that, when multiplied by itself, equals a. The square root obtained using a calculator is the principal square root. The principal square root of a is written as letter 1d44e square. The symbol is called a radical, the term under the symbol is called the radicand, and the entire expression is called a radical expression. The expression, square root of 25, is enclosed in a circle. The circle has an arrow pointing to it labeled radical expression. The square root symbol has an arrow pointing to it labeled radical. The number 25 has an arrow pointing to it labeled radicand. Principal square root. The principal square root of a is the non-negative number that, when multiplied by itself, equals a. It is written as a radical expression, with a symbol called a radical over the term called the radicand, letter 1d44e square. Q and a. Does 25 square equals plus 5? No. Although both 52 and minus 5, 2 are 25, the radical symbol implies only a non-negative root, the principal square root. The principal square root of 25 is 25 square equals 5. Example 1. Evaluating square roots. Evaluate each expression. A 100 square b 16 square square c, 25 plus 144 square d, 49 square minus 81 square. Solution. A 100 square equals 10. Because 102 equals 100b 16 square equals 4 square equals 2. Because 42 equals 16 and 22 equals 4c 25 plus 140, 4 square equals 169 square equals 13. Because 132 equals 169d 49 square minus 81 square equals 7 minus 9 equals minus 2. Because 72 equals 49 and 92 equals 81. Q and a for 25 plus 144 square. Can we find the square roots before adding? Number 25 square plus 144 square equals 5 plus 12 equals 17. This is not equivalent to 25 plus 144 square equals 13. The order of operations requires us to add the terms in the radicand before finding the square root. Try it. 1. Evaluate each expression. A 225 square b, 81 square c, 25 minus 9 square d, 36 square plus 121 square. Using the product rule to simplify square roots to simplify a square root. We rewrite it such that there are no perfect squares in the radicand. There are several properties of square roots that allow us to simplify complicated radical expressions. The first rule we will look at is the product rule for simplifying square roots, which allows us to separate the square root of a product of two numbers into the product of two separate rational expressions. For instance, we can rewrite 15 square as 3 square 5 square. We can also use the product rule to express the product of multiple radical expressions as a single radical expression. The product rule for simplifying square roots if a and b are non-negative. The square root of the product ob is equal to the product of the square roots of a and b. Letter 1d44e letter 1d44f square equals letter 1d44e square letter 1d44f square. Root how to given a square root radical expression. Use the product rule to simplify it. Factor any perfect squares from the radicand. Write the radical expression as a product of radical expressions. Simplify. Example 2, using the product rule to simplify square roots, simplify the radical expression. A 300 square B 162 letter 1d44e, 5 letter 1d44f, 4 square solution. 103 square 100 square 3 square 103 square factor perfect square from radicand. Write radical expression as product of radical expressions. Simplify. B 81 letter 1d44e, 4 letter 1d44f, 4 2 letter 1d44e square 80, 1 letter 1d44e, 4 letter 1d44f, 4 square 2 letter 1d44e square 9 letter 1d44e to letter 1d44f, 22 letter 1d44e square factor perfect square from radicand. Write radical expression as product of radical expressions. Simplify. Try it 2, simplify 50 x to letter 1d466, 3, letter 1d467 square. How to given the product of multiple radical expressions, use the product rule to combine them into one radical expression. Express the product of multiple radical expressions as a single radical expression. Simplify. Example 3, using the product rule to simplify the product of multiple square roots, simplify the radical expression. 12 square 3 square solution, 12 3 square 36 square 6, express the product as a single radical expression. Simplify. Try it 3 simplify 50 letter 1d465 square, 2 letter 1d465 square, assuming letter 1d4650. Using the quotient rule to simplify square roots, just as we can rewrite the square root of a product as a product of square roots. So too can we rewrite the square root of a quotient as a quotient of square roots, using the quotient rule for simplifying square roots. It can be helpful to separate the numerator and denominator of a fraction under a radical so that we can take their square roots separately. We can rewrite 52 square as 5 square root 2 square root. The quotient rule for simplifying square roots, the square root of the quotient ob, is equal to the quotient of the square roots of a and b, where letter 1d44f not equal to 0. Letter 1d44e letter 1d44f square equals letter 1d44e square letter 1d44f square. Root how to given a radical expression. Use the quotient rule to simplify it. Write the radical expression as the quotient of two radical expressions. Simplify the numerator and denominator. Example 4, using the quotient rule to simplify square roots, simplify the radical expression. 536 square solution, 5 square root 36 square root, 5 square root 6 write as quotient of two radical expressions. Simplify denominator. Try it 4 simplify 2 letter 1d465 29, letter 1d466 4 square. Example 5, using the quotient rule to simplify an expression with two square roots, simplify the radical expression. 234 letter 1d465 11 letter 1d466 square root, 26 letter 1d465, 7 letter 1d466 square root solution, 234 letter 1d465 11 letter 1d466, 26 letter 1d465, 7 letter 1d466 square 9 letter 1d465, 4 square 3 letter 1d465, 2 combine numerator and denominator into one radical. Expression. Simplify fraction. Simplify square root. Try it 5 simplify 9 letter 1d44e, 5 letter 1d44f, 14 square root 3 letter 1d44e, 4 letter 1d44f, 5 square root. Adding and subtracting square roots, we can add or subtract radical expressions only when they have the same radicand, and when they have the same radical type such as square roots. For example, the sum of 2 square and 32 square is 42 square. However, it is often possible to simplify radical expressions, and that may change the radicand. The radical expression 18 square can be written with a 2 in the radicand as 32 square, so 2 square plus 18 square equals 2 square plus 32 square equals 42 square. How to given a radical expression requiring addition or subtraction of square roots, simplify. Simplify each radical expression. Add or subtract expressions with equal radicands. Example 6, adding square roots, add 512 square plus 23 square. Solution, we can rewrite 512 square as 54 3 square. According the product rule, this becomes 54 square 3 square. The square root of 4 square is 2, so the expression becomes 5, 2, 3 square, which is 103 square. Now the terms have the same radicand, so we can add. 103 square plus 23 square equals 123 square. Try, it's 6 add 5 square plus 620 square. Example 7, subtracting square roots, subtract 2072 letter 1d44e, 3 letter 1d44f, 4 letter 1d450, square minus 148 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square. Solution, factor 9 out of the first term, so that both terms have equal radicands. 2072 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square equals 209, 8 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square 20. 3 8 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square equals 209 square 8 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square 600. So, 2072 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square minus 140, 8 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square equals 608 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square minus 148 letter 1d44e, 3 letter 1d44f, 4 letter 1d450 square equals 406. Try it 7. Subtract 380 letter 1d465 square minus 445 letter 1d465 square. Rationalizing denominators when an expression involving square root radicals is written in simplest form, it will not contain a radical in the denominator. We can remove radicals from the denominators of fractions using a process called rationalizing the denominator. We know that multiplying by 1 does not change the value of an expression. We use this property of multiplication to change expressions that contain radicals in the denominator. To remove radicals from the denominators of fractions, multiply by the form of 1 that will eliminate the radical. For a denominator containing a single term, multiply by the radical in the denominator over itself. In other words, if the denominator is letter 1d44f letter 1d450 square root, multiply by letter 1d450 square root letter 1d450 square root. For a denominator containing the sum or difference of a rational and an irrational term, multiply the numerator and denominator by the conjugate of the denominator, which is found by changing the sign of the radical portion of the denominator. If the denominator is letter 1d44e plus letter 1d44f letter 1d450 square root, then the conjugate is letter 1d44e minus letter 1d44f letter 1d450 square root. How to given an expression with a single square root radical term in the denominator, rationalize the denominator. Multiply the numerator and denominator by the radical in the denominator. Simplify. Example 8, rationalizing a denominator containing a single term, write 23 square root 310 square root in simplest form. Solution, the radical in the denominator is 10 square. So multiply the fraction by 10 square root 10 square root. Then simplify. 23 square root 310 square 10 square root 10 square root 230 square root 30 square root 15. Try it 8. Write 123 square root 2 square root in simplest form. How to given an expression with a radical term and a constant in the denominator, rationalize the denominator. Find the conjugate of the denominator. Multiply the numerator and denominator by the conjugate. Use the distributive property. Simplify. Example 9, rationalizing a denominator containing two terms, write 41 plus 5 square root in simplest form. Solution, begin by finding the conjugate of the denominator by writing the denominator and changing the sign. So the conjugate of 1 plus 5 square is 1 minus 5 square. Then multiply the fraction by 1 minus 5 square root 1 minus 5 square root. 41 plus 5 square 1 minus 5 square root 1 minus 5 square root 4 minus 45 square minus 45 square minus 1. Use the distributive property. Simplify. Try it 9 right 72 plus 3 square root in simplest form. Using rational roots, although square roots are the most common rational roots, we can also find cube roots, fourth roots, fifth roots, and more. Just as the square root function is the inverse of the squaring function, these roots are the inverse of their respective power functions. These functions can be useful when we need to determine the number that, when raised to a certain power, gives a certain number. Understanding nth roots, suppose we know that letter 1 d44e3 equals 8. We want to find what number raised to the third power is equal to 8. Since 23 equals 8, we say that 2 is the cube root of 8. The nth root of a is a number that, when raised to the nth power, gives. For example, minus 3 is the fifth root of minus 243, because minus 3, 5 equals minus 243. If a is a real number with at least one nth root, then the principal nth root of a is the number with the same sign as a that, when raised to the nth power, equals a. The principal nth root of a is written as letter 1 d44e square letter 1 d45b, where n is a positive integer greater than or equal to 2. In the radical expression, n is called the index of the radical. Principal nth root if it is a real number with at least one nth root, then the principal nth root of a, written as letter 1 d44e square letter 1 d45b, is the number with the same sign as a that, when raised to the nth power, equals a. The index of the radical is n example 10, simplifying nth roots simplify each of the following. A minus 32 square 5 b 4 square 4 1. C minus 8 letter 1 d4 6 5 6125 square 3. D 83 square 4 minus 48 square 4 solution. A minus 32 square 5 equals minus 2. Because minus 2 5 equals minus 32 be first. Express the product as a single radical expression. 4, 096 square 4 equals 8 because 84 equals 4. 096c minus 8, letter 1 d465, 6 square root 3125 square, root 3 minus 2 letter 1 d465 25. Write as quotient of two radical expressions. Simplify, d83 square 4 minus 23 square 463 square 4, simplify to get equal radicands. Add, try it 10 simplify. A minus 216 square 3, b 380 square root, 45 square root, for c 69. 000 square 3 plus 7,576 square 3, using rational exponents radical expressions, can also be written without using the radical symbol. We can use rational fractional exponents. The index must be a positive integer. If the index n is even, then a cannot be negative. Letter 1 d44e, 1 letter 1 d45b, equals letter 1 d44e square letter 1 d45b. We can also have rational exponents with numerators other than 1. In these cases, the exponent must be a fraction in lowest terms. We raise the base to a power and take an nth root. The numerator tells us the power, and the denominator tells us the root. Letter 1 d44e letter 1 d45a letter 1 d45b equals letter 1 d44e square letter 1 d45b, letter 1 d45a, equals letter 1 d44e letter 1 d45a, square letter 1 d45b. All of the properties of exponents that we learned for integer exponents also hold for rational exponents. Rational exponents are another way to express principal nth roots. The general form for converting between a radical expression with a radical symbol and one with a rational exponent is letter 1 d44e letter 1 d45a letter 1 d45b equals letter 1 d44e square letter 1 d45b letter 1 d45a equals letter 1 d44e letter 1 d45a square letter 1 d45b. How to give an expression with a rational exponent. Write the expression as a radical. Determine the power by looking at the numerator of the exponent. Determine the root by looking at the denominator of the exponent. Using the base as the radicand, raise the radicand to the power and use the root as the index. Example 11, writing rational exponents. As radicals, write 34,323 as a radical. Simplify. Solution, the 2 tells us the power and the 3 tells us the root. 34,323 equals 343 square 3. 2 equals 3,432 square 3. We know that 343 square 3 equals 7 because 73 equals 343. Because the cube root is easy to find, it is easiest to find the cube root before squaring for this problem. In general, it is easier to find the root first and then raise it to a power. 34,323 equals 343 square 3, 2 equals 72 equals 49. Try it 11. Write 952 as a radical. Simplify. Example 12, writing radicals as rational exponents, write 4-letter 1d44e2 square root 7 using a rational exponent. Solution: the power is 2 and the root is 7, so the rational exponent will be 27. We get 4a27. Using properties of exponents, we get 4-letter 1d44e2 square root 7 equals 4-letter 1d44e minus 27. Try it 12. Write letter 1d465, 5-letter 1d466, 9 square using a rational exponent. Example 13, simplifying rational exponents. Simplify. A5, 2-letter 1d465 34, 3-letter 1d465 15. B, 169 minus 12. Solution: 30x 34x 15 30x 34 plus 15 30x 19 20. Multiply the coefficients. Use properties of exponents. Simplify. B, 916, 12,916 square 9 square root 16 square root 34. Use definition of negative exponents. Rewrite as a radical. Use the quotient rule. Simplify. Try it 13. Simplify. 8-letter 1d465, 13, 14-letter 1d465 65. Media access: these online resources for additional instruction and practice with radicals and rational exponents. Radicals rational exponents. Simplify. Radicals rationalize denominator 1-3 section, exercises verbal 1. What does it mean when a radical does not have an index? Is the expression equal to the radicand? Explain. 2. Where would radicals come in the order of operations? Explain why. 3. Every number will have 2 square roots. What is the principal square root? 4. Can a radical with a negative radicand have a real square root? Why or why not? Numeric for the following exercises. Simplify each expression. 5 256 square 6, 256 square 7. 4, 9 plus 16 square 8, 289 square minus 121 square 9, 196 square 10, 1 square 11, 98 square 12, 2,764 square 13, 815 square 14, 800 square 15, 169 square plus 144 square 16, 850 square 17, 18,162 square root 18, 192 square 19, 146 square minus 624 square 20, 155 square plus 745 square 21, 150 square 22, 96,100 square 23, 42 square, 30 square, 24, 123 square minus 475 square 25, 4,225 square 26, 405,324 square 27, 360,361 square 28, 51 plus 3 square root 29, 81 minus 17 square root 30, 16 square 4 31, 128 square 3 plus 32 square 3 32, minus 32,243 square 533, 15,125 square root 45 square root 434, 3 minus 432 square 3 plus 16 square 3. Algebraic for the following exercises. Simplify each expression. 35. 400 letter 1d465 4 square 36. 4 letter 1d466 2 square 37. 49 letter 1d45d square 38. 144 peta letter 1d45e 6 at 1239. Letter 1d45a 52,289 square 40. 93 letter 1d45a 2 square plus 27 square 41. 3 letter 1d44 letter 1d44f 2 square minus letter 1d44f letter 1d44e square 42. 42 letter 1d45b square root 16 letter 1d45b 4 square root 43. 225, letter 1 d465, 349, letter 1 d465 square 44. 344, letter 1 d467 square plus 99, letter 1 d467 square 45. 50, letter 1 d466, 8 square 46. 490, letter 1 d44f, letter 1 d450, 2 square 47. 3214, letter 1 d451 square 48. Letter 1 d45e, 3263, letter 1 d45d square 49. 8 square root 1 minus 3, letter 1 d465 square, root 50. 20,121, letter 1 d451, 4 square 51. Letter 1 d464, 3,232, square minus letter 1 d464, 3,250 square 52. 108, letter 1 d465, 4 square plus 27, letter 1 d465, 4 square 53. 12, letter 1 d465 square, root 2, plus 23 square, root 54. 147, letter 1 d458, 3 square 55. 125, letter 1 d45b, 10 square 56. 42, letter 1 d45e, 36, letter 1 d45e, 3 square 57. 81, letter 1 d45a, 361, letter 1 d45a, 2 square 58. 72, letter 1 d450 square minus 22, letter 1 d450 square 59. 144,324, letter 1 d451, 2 square 60. 24, letter 1 d465, 6 square 3, plus 81, letter 1 d465, 6 square 361. 162, letter 1 d465, 616, letter 1 d465, 4 square 462. 64, letter 1 d466 square, 363. 128, letter 1 d467 3 square 3, minus minus, 16, letter 1 d467 3 square 3, 64. 1, 0, 24, letter 1 d450, 10 square 5, real-world applications, 65. A guy wire for a suspension bridge runs from the ground diagonally to the top of the closest pylon to make a triangle. We can use the Pythagorean theorem to find the length of guy wire needed. The square of the distance between the wire on the ground and the pylon on the ground is 90,000 feet. The square of the height of the pylon is 160,000 feet. So the length of the guy wire can be found by evaluating 90,000 plus 160,000 square. What is the length of the guy wire? 66. A car accelerates at a rate of 6 minus 4 square root letter 1 d461 square root m slash s2, where t is the time in seconds after the car moves from rest. Simplify the expression. Extensions for the following exercises simplify each expression. 67. 8 square minus 16 square root 4 minus 2 square minus 21268. 432 minus 1,630. 2,813.69. Letter 1 d45a, letter 1 d45b, 3 square root letter 1 d44e to letter 1 d450, minus 3 square letter 1 d44e, minus 7 letter 1 d45b, minus 2 letter 1 d458 to letter 1 d450, 4 square root 70. Letter 1 d44e, letter 1 d44e, minus letter 1 d450 square, root 71. Letter 1 d465 64, letter 1 d466 square plus 4 letter 1 d466 square, root 128, letter 1 d466 square, root 72. 250, letter 1 d465 2 square root 100, letter 1 d44f 3 square root 7, letter 1 d44f square root 125, letter 1 d465 square root 73. 64 square root 3 plus 256 square root 464 square plus 256 square square. Learning objectives in this section, you will identify the degree and leading coefficient of polynomials, add and subtract polynomials, multiply polynomials, use FOIL to multiply binomials, perform operations with polynomials of several variables. Mahai is building a little free library, a small house-shaped book repository, whose front is in the shape of a square topped with a triangle. There will be a rectangular door through which people can take and donate books. Mahai wants to find the area of the front of the library so that they can purchase the correct amount of paint. Using the measurements of the front of the house, shown in Figure 1, we can create an expression that combines several variable terms, allowing us to solve this problem and others like it. Sketch of a house formed by a square and a triangle based on the top of the square. A rectangle is placed at the bottom center of the square to mark a doorway. The height of the door is labeled X and the width of the door is labeled 1 foot. The side of the square is labeled 2x. The height of the triangle is labeled 2 feet. Figure 1, first find the area of the square in square feet. Letter 1D434 equals letter 1D460 2 letter 1D465 24 letter 1D4652, then find the area of the triangle in square feet. Letter 1D434 equals 12 letter 1D44F letter 210E 12 2 letter 1D465 32 letter 1D465. Next find the area of the rectangular door in square feet. Letter 1D434 equals letter 1D459 letter 1D464 letter 1D465 1 letter 1D465. The area of the front of the library can be found by adding the areas of the square and the triangle, and then subtracting the area of the rectangle. When we do this, we get 4 letter 1D4652 plus 32 letter 1D465 minus letter 1D465 FT2, or 4x2 plus 12x FT2. In this section, we will examine expressions such as this one, which combines several variable terms. Identifying the degree and leading coefficient of polynomials, the formula just found is an example of a polynomial, which is a sum of or difference of terms, each consisting of a variable raised to a non-negative integer power. A number multiplied by a variable raised to an exponent, such as 384 letter 1D70b, is known as a coefficient. Coefficients can be positive, negative, or zero, and can be whole numbers, decimals, or fractions. Each product, letter 1D44, letter 1D456, letter 1D465, letter 1D456, such as 384 letter 1D70b, letter 1D464, is a term of a polynomial. If a term does not contain a variable, it is called a constant. A polynomial containing only one term, such as 5x4, is called a monomial. A polynomial containing two terms, such as 2 letter 1D465 minus 9, is called a binomial. A polynomial containing three terms, such as minus 3 letter 1D465 2 plus 8 letter 1D465 minus 7, is called a trinomial. We can find the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. The term with the highest degree is called the leading term because it is usually written first. The coefficient of the leading term is called the leading coefficient. When a polynomial is written so that the powers are descending, we say that it is in standard form. A polynomial reading. A sub n times x to the nth power plus, and so on, plus a sub 2 times x squared plus a sub 1 times x plus a sub 0 is shown. The a in the term a sub n is labeled leading coefficient. The n in the term x to the nth power is labeled degree. Finally, the entire term is labeled as leading term. Polynomials. A polynomial is an expression that can be written in the form letter 1D44, letter 1D45b, letter 1D465, letter 1D45b plus a2x2 plus a1x plus a0. Each real number ai is called a coefficient. The number a0 that is not multiplied by a variable is called a constant. Each product, letter 1D44, letter 1D456, letter 1D465, letter 1D456, is a term of a polynomial. The highest power of the variable that occurs in the polynomial is called the degree of a polynomial. The leading term is the term with the highest power, and its coefficient is called the leading coefficient. How to, given a polynomial expression, identify the degree and leading coefficient. Find the highest power of x to determine the degree. Identify the term containing the highest power of x to find the leading term. Identify the coefficient of the leading term. Example 1. Identifying the degree and leading coefficient of a polynomial for the following polynomials. Identify the degree, the leading term, and the leading coefficient. A3 plus 2 letter 1D465 2 minus 4 letter 1D465 3 B 5 letter 1 D4 6 1. 5 minus 2 letter 1 D4 6 1 3. Plus 7 letter 1 D4 6 1 C6 letter 1 D4 5D minus letter 1 D4 5D. 3 minus 2. Solution: A. The highest power of x is 3. So the degree is 3. The leading term is the term containing that degree, minus 4 letter 1 D4 6 5 3. The leading coefficient is the coefficient of that term, minus 4. B. The highest power of t is 5, so the degree is 5. The leading term is the term containing that degree, 5t5. The leading coefficient is the coefficient of that term, 5. C. The highest power of p is 3, so the degree is 3. The leading term is the term containing that degree, minus letter 1 d4 5d3. The leading coefficient is the coefficient of that term, minus 1. Try at 1. Identify the degree, leading term, and leading coefficient of the polynomial 4 letter 1 d4 6 5, 2 minus letter 1 d4 6 5, 6, plus 2 letter 1 d4 6 5 minus 6. Adding and subtracting polynomials, we can add and subtract polynomials by combining like terms, which are terms that contain the same variables raised to the same exponents. For example, 5x2 and minus 2 letter 1 d4 6 5 2 are like terms, and can be added to get 3x2. But 3x and 3x2 are not like terms, and therefore cannot be added. How to, given multiple polynomials, add or subtract them to simplify the expressions. Combine like terms. Simplify and write in standard form. Example 2. Adding polynomials, find the sum. 12 letter 1 d4 6 5 2 plus 9 letter 1 d4 6 5 minus 21 plus 4 letter 1 d4 6 5 3 plus 8 letter 1 d4 6 5 2 minus 5 letter 1 d4 6 5 plus 20. Solution: 4 letter 1 d4 6 5 3 plus 12 letter 1 d4 6 5 2 plus 8 letter 1 d4 6 5 2 plus 9 letter 1 d4 6 5 minus 5 letter 1 d4 6 5 plus minus 21 plus 20. 4 letter 1 d4 6 5 3 plus 20 letter 1 d4 6 5 2 plus 4 letter 1 d4 6 5 minus 1. Combine like terms. Simplify. Analysis: we can check our answers to these types of problems using a graphing calculator. To check, graph the problem as given along with the simplified answer. The two graphs should be equivalent. Be sure to use the same window to compare the graphs. Using different windows can make the expressions seem equivalent when they are not. Try it to find the sum. 2 letter 1 d4 6 5 3 plus 5 letter 1 d4 6 5 2 minus letter 1 d4 6 5 plus 1 plus 2 letter 1 d4 6 5 2 minus 3 letter 1 d4 6 5 minus 4. Example 3. Subtracting polynomials, find the difference. 7 letter 1 d4 6 5 4 minus letter 1 d4 6 5 2 plus 6 letter 1 d4 6 5 plus 1 minus 5 letter 1 d4 6 5 3 minus 2 letter 1 d4 6 5 2 plus 3 letter 1 d4 6 5 plus 2. Solution: 7 letter 1 d4 6 5 4 minus letter 1 d4 6 5 2 plus 6 letter 1 d4 6 5 plus 1 minus 5 letter 1 d4 6 5 3 plus 2 letter 1 d4 6 5 2 minus 3 letter 1 d4 6 5 minus 27 letter 1 d4 6 5 4 minus 5 letter 1 d4 6 5 3 plus letter 1 d4 6 5 2 plus 6 letter 1 d4 6 5 minus 3 letter 1 d4 6 5 plus 1 minus 27 letter 1 d. Negative sign. Group like terms. Combine, simplify. Analysis: note that finding the difference between two polynomials is the same as adding the opposite of the second polynomial to the first. Try it. 3. Find the difference. Minus 7 letter 1 d4 6 5 3 minus 7 letter 1 d4 6 5 2 plus 6 letter 1 d4 6 5 minus 2 minus 4 letter 1 d4 6 5 3 minus 6 letter 1 d4 6 5 2 minus letter 1 d4 6 5 plus 7. Multiplying polynomials is a bit more challenging than adding and subtracting polynomials. We must use the distributive property to multiply each term in the first polynomial by each term in the second polynomial. We then combine like terms. We can also use a shortcut called the FOIL method when multiplying binomials. Certain special products follow patterns that we can memorize and use instead of multiplying the polynomials by hand each time. We will look at a variety of ways to multiply polynomials. Multiplying polynomials using the distributive property to multiply a number by a polynomial, we use the distributive property. The number must be distributed to each term of the polynomial. We can distribute the 2 in 2, letter 1d465 plus 7, to obtain the equivalent expression 2x plus 14. When multiplying polynomials, the distributive property allows us to multiply each term of the first polynomial by each term of the second. We then add the products together and combine like terms to simplify. How to given the multiplication of two polynomials, use the distributive property to simplify the expression. Multiply each term of the first polynomial by each term of the second. Combine like terms. Simplify. Example 4. Multiplying polynomials using the distributive property, find the product. 2 letter 1d465 plus 1, 3 letter 1d465 2 minus letter 1d465, plus 4, solution 2 letter 1d465. 3 letter 1d465 2 minus letter 1d465 plus 4, plus 1, 3 letter 1d465 2 minus letter 1d465 plus 4. 6 letter 1d465 3 minus 2 letter 1d465 2, plus 8 letter 1d465, plus 3 letter 1d465 2 minus letter 1d465 plus 4, 6 letter 1d465 3 plus minus 2 letter 1d465 2, plus 3 letter 1d465 2, plus 8 letter 1d465 minus letter 1d465 plus 46 letter 1d465 3 plus letter 1d465 2, plus 7 letter. Use the distributive property. Multiply, combine like terms. Simplify. Analysis, we can use a table to keep track of our work, as shown in Table 1. Write one polynomial across the top and the other down the side. For each box in the table, multiply the term for that row by the term for that column. Then add all of the terms together, combine like terms, and simplify. 3x2 minus letter 1d465 plus 4 2x6 x3 minus 2, letter 1d465 2, 8x plus 1 3x2 minus letter 1d465. 4 table 1 try it 4 find the product. 3 letter 1d465 plus 2. Letter 1d465 3 minus 4 letter 1d465 2 plus 7. Using FOIL to multiply binomials, a shortcut called FOIL is sometimes used to find the product of two binomials. It is called FOIL because we multiply the first terms, the outer terms, the inner terms, and then the last terms of each binomial. Two quantities in parentheses are being multiplied, the first being a times x plus b and the second being c times x plus d. This expression equals ac times x squared plus add times x plus bc times x plus bd. The terms ax and cx are labeled first terms. The terms ax and d are labeled outer terms. The terms b and cx are labeled inner terms. The terms b and d are labeled last terms. The FOIL method arises out of the distributive property. We are simply multiplying each term of the first binomial by each term of the second binomial, and then combining like terms. How to given two binomials, use FOIL to simplify the expression. Multiply the first terms of each binomial. Multiply the outer terms of the binomials. Multiply the inner terms of the binomials. Multiply the last terms of each binomial. Add the products. Combine like terms and simplify. Example 5. Using FOIL to multiply binomials, use FOIL to find the product. 2 letter 1d465 minus 18. 3 letter 1d465 plus 3. Solution, find the product of the first terms. Find the product of the outer terms. Find the product of the inner terms. Find the product of the last terms. 6 letter 1d465 2 plus 6 letter 1d465 minus 54 letter 1d465 minus 546 letter 1d465 2 plus 6 letter 1d465 minus 54 letter 1d465 minus 546 letter 1d465 2 minus 48 letter 1d465 minus 54. Add the products. Combine like terms. Simplify. Try it 5. Use FOIL to find the product. Letter 1d465 plus 7, 3 letter 1d465 minus 5. Perfect square trinomials, certain binomial products have special forms. When a binomial is squared, the result is called a perfect square trinomial. We can find the square by multiplying the binomial by itself. However, there is a special form that each of these perfect square trinomials takes, and memorizing the form makes squaring binomials much easier and faster. Let's look at a few perfect square trinomials to familiarize ourselves with the form. Letter 1d465 plus 5, 2. Letter 1d465 minus 3, 2. 4 letter 1d465 minus 1, 2 equals letter 1d465 2 plus 10 letter 1d465 plus 25 letter 1d465 2 minus 6 letter 1d465 plus 916 letter 1d465 2 minus 8 letter 1d465 plus 1. Notice that the first term of each trinomial is the square of the first term of the binomial, and similarly, the last term of each trinomial is the square of the last term of the binomial. The middle term is double the product of the two terms. Lastly, we see that the first sign of the trinomial is the same as the sign of the binomial. Perfect square trinomials, when a binomial is squared, the result is the first term squared added to double the product of both terms and the last term squared. Letter 1d465 plus letter 1d442 equals letter 1d465 plus letter 1d440. Letter 1d465 plus letter 1d440 equals letter 1d465 2 plus 2 letter 1d440 letter 1d465 plus letter 1d440 2. How to given a binomial? Square it using the formula for perfect square trinomials. Square the first term of the binomial. Square the last term of the binomial. For the middle term of the trinomial, double the product of the two terms. Add and simplify. Example 6. Expanding perfect squares. Expand 3 letter 1d465 minus 8, 2. Solution. Begin by squaring the first term and the last term. For the middle term of the trinomial, double the product of the two terms. 3 letter 1d465, 2 minus 2, 3 letter 1d465, 8 plus minus 8, 2. Simplify. 9 letter 1d465, 2 minus 48 letter 1d465 plus 64. Try it. 6. Expand 4 letter 1d465 minus 1, 2. Difference of squares. Another special product is called the difference of squares, which occurs when we multiply a binomial by another binomial with the same terms but the opposite sign. Let's see what happens when we multiply letter 1d465 plus 1, letter 1d465 minus 1, using the FOIL method. Letter 1d465 plus 1, letter 1d465 minus 1 equals letter 1d465 2 minus letter 1d465 plus letter 1d465 minus 1 letter 1d465 2 minus 1. The middle term drops out, resulting in a difference of squares. Just as we did with the perfect squares, let's look at a few examples. Letter 1d465 plus 5. Letter 1d465 minus 5. Letter 1d465 plus 11. Letter 1d465 minus 11. 2 letter 1d465 plus 3. 2 letter 1d465 minus 3 equals letter 1d465 2 minus 25 letter 1d465 2 minus 1214 letter 1d465 2 minus 9, because the sign changes in the second binomial. The outer and inner terms cancel each other out, and we are left only with the square of the first term minus the square of the last term. Q and A. Is there a special form for the sum of squares? No. The difference of squares occurs because the opposite signs of the binomials cause the middle terms to disappear. There are no two binomials that multiply to equal a sum of squares. Difference of squares when a binomial is multiplied by a binomial with the same terms separated by the opposite sign. The result is the square of the first term minus the square of the last term. Letter 1d440 plus letter 1d44f. Letter 1d440 minus letter 1d44f equals letter 1d440, 2 minus letter 1d44f, 2. How to given a binomial multiplied by a binomial with the same terms but the opposite sign. Find the difference of squares. Square the first term of the binomials. Square the last term of the binomials. Subtract the square of the last term from the square of the first term. Example 7. Multiplying binomials resulting in a difference of squares. Multiply 9 letter 1d465 plus 4, 9 letter 1d465 minus 4. Solution. Square the first term to get 9 letter 1d465 2 equals 81 letter 1d465 2. Square the last term to get 42 equals 16. Subtract the square of the last term from the square of the first term to find the product of 81 letter 1d465 2 minus 16. Try it. 7. Multiply 2 letter 1d465 plus 7, 2 letter 1d465 minus 7. Performing operations with polynomials of several variables, we have looked at polynomials containing only one variable. However, a polynomial can contain several variables. All of the same rules apply when working with polynomials containing several variables. Consider an example. Letter 1d44e plus 2 letter 1d44f. 4 letter 1d44e minus letter 1d44f minus letter 1d450. Letter 1d44e. 4 letter 1d44e minus letter 1d44f minus letter 1d450 plus 2 letter 1d44f. 4 letter 1d44e minus letter 1d44f minus letter 1d450. 4 letter 1d44e 2 minus letter 1d44e letter 1d44f minus letter. To use the distributive property, multiply, combine like terms. Simplify. Example 8 multiplying polynomials containing several variables multiply letter 1d465 plus 4, 3 letter 1d465 minus 2 letter 1d466 plus 5. Solution follow the same steps that we used to multiply polynomials containing only one variable. Letter 1d465, 3 letter 1d465 minus 2 letter 1d466 plus 5, plus 4, 3 letter 1d465 minus 2 letter 1d466 plus 5. 3 letter 1d465 2 minus 2 letter 1d465 letter 1d466 plus 5 letter 1d465 plus 12 letter 1d465 minus 8 letter 1d466 plus 203 letter 1d465 2 minus 2 letter 1d465 letter 1d466 plus 5 letter 1d465 plus 12 letter 1d465 minus 8 letter 1d466 plus 203 letter 1d465 2. Use the distributive property. Multiply, combine like terms. Simplify. Try at 8 multiply, 3 letter 1d465 minus 1, 2 letter 1d465 plus 7 letter 1d466 minus 9. Media access, these online resources for additional instruction and practice with polynomials. Adding and subtracting polynomials, multiplying polynomials, special products of polynomials 1. 4-section exercises verbal 1. Evaluate the following statement. The degree of a polynomial in standard form is the exponent of the leading term. Explain why the statement is true or false. 2. Many times, multiplying two binomials with two variables results in a trinomial. This is not the case when there is a difference of two squares. Explain why the product in this case is also a binomial. 3. You can multiply polynomials with any number of terms and any number of variables using 4 basic steps over and over until you reach the expanded polynomial. What are the 4 steps? 4. State whether the following statement is true and explain why or why not. A trinomial is always a higher degree than a monomial. Algebraic for the following exercises, identify the degree of the polynomial. 5. 7 letter 1d465 minus 2 letter 1d465 2 plus 13 6. 14 letter 1d45a 3 plus letter 1d45a 2 minus 16 letter 1d45a plus 8 7. Minus 625 letter 1d44e 8 plus 16 letter 1d44f 4 8. 200 letter 1d45d minus 30 letter 1d45d2m plus 40m 3 9. x2 plus 4x plus 4 10. 6 letter 1d466 4 minus letter 1d466 5 plus 3 letter 1d466 minus 4. For the following exercises, find the sum or difference. 11. 12 letter 1d465 2 plus 3 letter 1d465 minus 8 letter 1d465 2 minus 19 12. 4 letter 1d467 3 plus 8 letter 1d467 2 minus letter 1d467 plus minus 2 letter 1d467 2 plus letter 1d467 plus 6 13. 6 letter 1d464 2 plus 24 letter 1d464 plus 24 minus 3 letter 1d464 minus 26 letter 1d464 plus 3 14. 7 letter 1d44e 3 plus 6 letter 1d44e 2 minus 4 letter 1d44e minus 13 plus minus 3 letter 1d44e 3 minus 4 letter 1d44e 2 plus 6 letter 1d44e plus 17 15. 11 letter 1d44f 4 minus 6 letter 1d44f 3 plus 18 letter 1d44f 2 minus 4 letter 1d44f plus 8 minus 3 letter 1D44F, 3 plus 6 letter 1D44F, 2 plus 3 letter 1D44F. 16. 49 letter 1D45D, 2 minus 25 plus 16 letter 1D45D, 4 minus 32 letter 1D45D, 2 plus 16. For the following exercises, find the product. 17. 4 letter 1D465 plus 2, 6 letter 1D465 minus 4, 18. 14 letter 1D450, 2 plus 4 letter 1D450. 2 letter 1D450, 2 minus 3 letter 1D450, 19. 6 letter 1D44F, 2 minus 6. 4 letter 1D44F, 2 minus 4, 20. 3 letter 1D451 minus 5. 2 letter 1D451 plus 9, 21. 9 letter 1D463 minus 11. 11 letter 1D463 minus 9, 22. 4 letter 1D4612 plus 7 letter 1D461. Minus 3 letter 1D4612 plus 4, 23. 8 letter 1D45B minus 4, letter 1D45B 2 plus 9. For the following exercises, expand the binomial. 24. 4 letter 1D465 plus 5, 2, 25. 3 letter 1D466 minus 7, 2, 26. 12 minus 4 letter 1D465, 2, 27. 4 letter 1D45D plus 9, 2, 28. 2 letter 1D45A minus 3, 2, 29. 3 letter 1D466 minus 6, 2, 30. 9 letter 1D44F plus 1, 2. For the following exercises, multiply the binomials. 31. 4 letter 1D450 plus 1, 4 letter 1D450 minus 1, 32. 9 letter 1D44E minus 4, 9 letter 1D44E plus 4, 33. 15 letter 1D45B minus 6, 15 letter 1D45B plus 6, 34. 25 letter 1D44F plus 2, 25 letter 1D44F minus 2, 35. 4 plus 4 letter 1D45A, 4 minus 4 letter 1D45A, 36. 14 letter 1D45D plus 7, 14 letter 1D45D minus 7, 37. 11 letter 1D45E minus 10, 11 letter 1D45E plus 10. For the following exercises, multiply the polynomials. 38. 2 letter 1D465 2 plus 2 letter 1D465 plus 1, 4 letter 1D465 minus 1, 39. 4 letter 1D461 2 plus letter 1D461 minus 7. 4 letter 1D461 2 minus 1, 40. Letter 1D465 minus 1, letter 1D465 2 minus 2 letter 1D465 plus 1, 41. Letter 1D466 minus 2, letter 1D466 2 minus 4 letter 1D466 minus 9, 42. 6 letter 1D458 minus 5, 6 letter 1D458 2 plus 5 letter 1D458 minus 1, 43. 3 letter 1D45D2 plus 2 letter 1D45D minus 10, letter 1D45D minus 1, 44. 4 letter 1D45A minus 13, 2 letter 1D45A, 2 minus 7 letter 1D45A plus 9, 45. Letter 1D44E plus letter 1D44F, letter 1D44E minus letter 1D44F, 46. 4 letter 1D465 minus 6 letter 1D466, 6 letter 1D465 minus 4 letter 1D466, 47. 4 letter 1D461 minus 5 letter 1D462, 248. 9 letter 1D45A plus 4 letter 1D45B minus 1, 2 letter 1D45A plus 8, 49. 4 letter 1D461 minus letter 1D465, letter 1D461 minus letter 1D465 plus 1, 50. Letter 1D44F 2 minus 1, letter 1D44E 2 plus 2 letter 1D44E letter 1D44F plus letter 1D44F 2, 51. 4 letter 1D45F minus letter 1D451. 6 letter 1D45F plus 7 letter 1D451, 52. Letter 1D465 plus letter 1D466. Letter 1D465 2 minus letter 1D465 letter 1D466 plus letter 1D466 2, real-world applications 53. A developer wants to purchase a plot of land to build a house. The area of the plot can be described by the following expression: 4 letter 1d465 plus 1, 8 letter 1d465 minus 3, where x is measured in meters. Multiply the binomials to find the area of the plot in standard form. 54. A prospective buyer wants to know how much grain a specific silo can hold. The area of the floor of the silo is 2 letter 1d465 plus 9, 2. The height of the silo is 10x plus 10, where x is measured in feet. Expand the square and multiply by the height to find the expression that shows how much grain the silo can hold. Extensions for the following exercises perform the given operations. 55. 4 letter 1d461 minus 7, 2. 2 letter 1d461 plus 1 minus 4 letter 1d461 2 plus 2 letter 1d461 plus 11. 56. 3 letter 1d44f plus 6. 3 letter 1d44f minus 6. 9 letter 1d44f 2 minus 36. 57. Letter 1d44e2 plus 4 letter 1d44 letter 1d450 plus 4 letter 1d4502. Letter 1d44e2 minus 4 letter 1d4502. Learning objectives in this section, you will factor the greatest common factor of a polynomial, factor a trinomial, factor by grouping, factor a perfect square trinomial, factor a difference of squares, factor the sum and difference of cubes, factor expressions using fractional or negative exponents. Imagine that we are trying to find the area of a lawn so that we can determine how much grass seed to purchase. The lawn is the green portion in Figure 1, a large rectangle with smaller squares and a rectangle inside. The length of the outer rectangle is 6x and the width is 10x. The side length of the squares is 4 and the height of the width of the inner rectangle is 4. Figure 1, the area of the entire region can be found using the formula for the area of a rectangle. Letter 1d434 equals letter 1d459 letter 1d464, 10 letter 1d4656, letter 1d46560, letter 1d465 units to the areas of the portions that do not require grass seed need to be subtracted from the area of the entire region. The two square regions each have an area of letter 1d434 equals letter 1d460, 2 equals 42 equals 16 units 2. The other rectangular region has one side of length 10 letter 1d465 minus 8 and one side of length 4, giving an area of letter 1d434 equals letter 1d459 letter 1d464 equals 4. 10 letter 1d465 minus 8 equals 40 letter 1d465 minus 32 units 2. So the region that must be subtracted has an area of 2. 16 plus 40 letter 1d465 minus 32 equals 40 letter 1d465 units 2. The area of the region that requires grass seed is found by subtracting 60 letter 1d465 2 minus 40 letter 1d465 units 2. This area can also be expressed in factored form as 20 letter 1d465, 3 letter 1d465 minus 2, units 2. We can confirm that this is an equivalent expression by multiplying. Many polynomial expressions can be written in simpler forms by factoring. In this section, we will look at a variety of methods that can be used to factor polynomial expressions. Factoring the greatest common factor of a polynomial when we study fractions, we learn that the greatest common factor, GCF, of two numbers is the largest number that divides evenly into both numbers. For instance, 4 is the GCF of 16 and 20, because it is the largest number that divides evenly into both 16 and 20. The GCF of polynomials works the same way. 4x is the GCF of 16x and 20x too, because it is the largest polynomial that divides evenly into both 16x and 20x too. When factoring a polynomial expression, our first step should be to check for a GCF. Look for the GCF of the coefficients, and then look for the GCF of the variables. Greatest common factor, the greatest common factor, GCF, of polynomials is the largest polynomial that divides evenly into the polynomials. How to, given a polynomial expression, factor out the greatest common factor. Identify the GCF of the coefficients. Identify the GCF of the variables. Combine to find the GCF of the expression. Determine what the GCF needs to be multiplied by to obtain each term in the expression. Write the factored expression as the product of the GCF and the sum of the terms we need to multiply by. Example 1, factoring the greatest common factor 6x3y3 plus 45 x to letter 1d466, 2 plus 21 letter 1d465 letter 1d466. Solution first, find the GCF of the expression. The GCF of 6, 45, and 21 is 3. The GCF of x3, x2, and x is x. Note that the GCF of a set of expressions in the form letter 1d465 letter 1d45b will always be the exponent of lowest degree. And the GCF of y3, y2, and y is y. Combine these to find the GCF of the polynomial 3 letter 1d465 letter 1d466. Next, determine what the GCF needs to be multiplied by to obtain each term of the polynomial. We find that 3 letter 1d465 letter 1d466, 2 letter 1d465 to letter 1d4662 equals 6 letter 1d465, 3 letter 1d4663, 3 letter 1d465 letter 1d466, 15 letter 1d465 letter 1d466 equals 45 letter 1d465 to y2. And finally, write the factored expression as the product of the GCF and the sum of the terms we needed to multiply by. 3 letter 1d465 letter 1d466, 2 letter 1d465 to letter 1d466, 2 plus 15 letter 1d465 letter 1d466 plus 7, analysis after factoring, we can check our work by multiplying. Use the distributive property to confirm that 3 letter 1d465 letter 1d466, 2 letter 1d465 to letter 1d466, 2 plus 15 letter 1d465 letter 1d466 plus 7 equals 6 letter 1d465, 3 letter 1d4663 plus 45 letter 1d465 to letter 1d466, 2 plus 21 letter 1d465 letter 1d466. Try it one factor letter 1d465, letter 1d44f 2 minus letter 1d44e plus 6, letter 1d44f 2 minus letter 1d44e by pulling out the GCF. Factoring a trinomial with leading coefficient 1, although we should always begin by looking for a GCF. Pulling out the GCF is not the only way that polynomial expressions can be factored. The polynomial x2 plus 5x plus 6 has a GCF of 1, but it can be written as the product of the factors x plus 2 and x plus 3. Trinomials of the form letter 1d465, 2 plus letter 1d44f letter 1d465 plus letter 1d450 can be factored by finding two numbers with a product of c and a sum of b. The trinomial x2 plus 10x plus 16, for example, can be factored using the numbers 2 and 8 because the product of those numbers is 16 and their sum is 10. The trinomial can be rewritten as the product of x plus 2 and x plus 8. Factoring a trinomial with leading coefficient 1, a trinomial of the form letter 1d465, 2 plus letter 1d44f letter 1d465 plus letter 1d450 can be written in factored form as letter 1d465 plus letter 1d45d, letter 1d465 plus letter 1d45e, where letter 1d45d letter 1d45e equals letter 1d450 and letter 1d45d plus letter 1d45e equals letter 1d44f. Q and A, can every trinomial be factored as a product of binomials? No, some polynomials cannot be factored. These polynomials are said to be prime. How to given a trinomial in the form letter 1d465, 2 plus letter 1d44f letter 1d465 plus letter 1d450, factor it. List factors of C, find P and Q. A pair of factors of C with a sum of B. Write the factored expression letter 1d465 plus letter 1d45d, letter 1d465 plus letter 1d45e. Example 2, factoring a trinomial with leading coefficient 1 factor letter 1d465, 2 plus 2 letter 1d465 minus 15. Solution, we have a trinomial with leading coefficient 1, letter 1d44f equals 2, and letter 1d450 equals minus 15. We need to find two numbers with a product of minus 15 and a sum of 2. In the table below, we list factors until we find a pair with the desired sum. Factors of minus 15, sum of factors 1, minus 15 minus 14 minus 1, 15, 14, 3, minus 5, minus 2, minus 3. 5, 2. Now that we have identified P and Q as minus 3 and 5, write the factored form as letter 1d465 minus 3. Letter 1d465 plus 5. Analysis, we can check our work by multiplying. Use FOIL to confirm that letter 1d465 minus 3. Letter 1d465 plus 5 equals letter 1d465 2 plus 2 letter 1d465 minus 15. Q and A, does the order of the factors matter? No. Multiplication is commutative, so the order of the factors does not matter. Try it 2-factor letter 1d465, 2 minus 7 letter 1d465 plus 6. Factoring by grouping trinomials with leading coefficients other than 1 are slightly more complicated to factor. For these trinomials, we can factor by grouping by dividing the x term into the sum of two terms, factoring each portion of the expression separately, and then factoring out the GCF of the entire expression. The trinomial 2x2 plus 5x plus 3 can be rewritten as 2 letter 1d465 plus 3. Letter 1d465 plus 1. Using this process, we begin by rewriting the original expression as 2x2 plus 2x plus 3x plus 3, and then factor each portion of the expression to obtain 2 letter 1d465. Letter 1d465 plus 1 plus 3. Letter 1d465 plus 1. We then pull out the GCF of x plus 1 to find the factored expression. Factor by grouping to factor a trinomial in the form letter 1d44 letter 1d465, 2 plus letter 1d44f letter 1d465 plus letter 1d450 by grouping. We find two numbers with a product of letter 1d44 letter 1d450 and a sum of b. We use these numbers to divide the x term into the sum of two terms and factor each portion of the expression separately. Then factor out the GCF of the entire expression. How to given a trinomial in the form letter 1d44 letter 1d465, 2 plus letter 1d44f letter 1d465 plus letter 1d450. Factor by grouping. List factors of letter 1d44 letter 1d450. Find P and Q, a pair of factors of letter 1d44 letter 1d450 with a sum of b. Rewrite the original expression as letter 1d44 letter 1d465, 2 plus letter 1d45d letter 1d465 plus letter 1d45 letter 1d465 plus letter 1d450. Pull out the GCF of letter 1d44 letter 1d465, 2 plus letter 1d45d letter 1d465. Pull out the GCF of letter 1d45 letter 1d465 plus letter 1d450. Factor out the GCF of the expression. Example 3, factoring a trinomial by grouping factor 5 letter 1d465 2 plus 7 letter 1d465 minus 6 by grouping. Solution, we have a trinomial with letter 1d44e equals 5, letter 1d44f equals 7, and letter 1d450 equals minus 6. First, determine letter 1d44 letter 1d450 equals minus 30. We need to find two numbers with a product of minus 30 and a sum of 7. In the table below, we list factors until we find a pair with the desired sum. Factors of minus 30 sum of factors, minus 29 minus 1, 30 29 2, minus 15 minus 13 minus 2, 15 13 3, minus 10 minus 7 minus 3. 10, 7, so letter 1d45d equals minus 3 and letter 1d45e equals 10. 5 letter 1d465 2 minus 3 letter 1d465 plus 10 letter 1d465 minus 6. Rewrite the original expression as letter 1d44 letter 1d465 2 plus letter 1d45d letter 1d465 plus letter 1d45 letter 1d465 plus letter 1d450. Factor out the GCF of each part. Factor out the GCF of the expression. Analysis, we can check our work by multiplying. Use FOIL to confirm that 5 letter 1d465 minus 3, letter 1d465 plus 2 equals 5 letter 1d465 2 plus 7 letter 1d465 minus 6. Try it 3-factor a2x2 plus 9x plus 9b 6 letter 1d465 2 plus letter 1d465 minus 1. Factoring a perfect square trinomial, a perfect square trinomial, is a trinomial that can be written as the square of a binomial. Recall that when a binomial is squared, The result is the square of the first term added to twice the product of the two terms and the square of the last term. A2 plus 2 ob plus beta letter 1 d4 4e, 2 minus 2 letter 1 d4 4e letter 1 d4 4f, plus letter 1 d4 4f, 2 equals and equals. Letter 1 d4 4e plus letter 1 d4 4f at 2, letter 1 d4 4e minus letter 1 d4 4f. 2. We can use this equation to factor any perfect square trinomial. Perfect square trinomials. A perfect square trinomial can be written as the square of a binomial. Letter 1 d4 4e 2 plus 2 letter 1 d4 4e letter 1 d4 4f plus letter 1 d4 4f 2 equals. Letter 1 d4 4e plus letter 1 d4 4f. 2. How to given a perfect square trinomial, factor it into the square of a binomial. Confirm that the first and last term are perfect squares. Confirm that the middle term is twice the product of ob. Write the factored form as letter 1 d4 4e plus letter 1 d4 4f2. Example 4. Factoring a perfect square trinomial factor 25x2 plus 20x plus 4. Solution. Notice that 25x2 and 4 are perfect squares because 25 letter 1 d4 6 5 2 equals 5 letter 1 d4 6 5 2 and 4 equals 22. Then check to see if the middle term is twice the product of 5x and 2. The middle term is indeed twice the product. 2, 5 letter 1 d4 6 5. 2 equals 20 letter 1 d4 6 5. Therefore, the trinomial is a perfect square trinomial and can be written as 5 letter 1 d4 6 5 plus 2 2. Try it. 4 factor 49 letter 1 d4 6 5, 2 minus 14 letter 1 d4 6 5 plus 1. Factoring a difference of squares. A difference of squares is a perfect square subtracted from a perfect square. Recall that a difference of squares can be rewritten as factors containing the same terms but opposite signs because the middle terms cancel each other out when the two factors are multiplied. Letter 1 d4 4e 2 minus letter 1 d4 4f 2 equals letter 1 d4 4e plus letter 1 d4 4f. Letter 1 d4 4e minus letter 1 d4 4f. We can use this equation to factor any differences of squares. Differences of squares. A difference of squares can be rewritten as two factors containing the same terms but opposite signs. Letter 1 d4 4e 2 minus letter 1 d4 4f 2 equals letter 1 d4 4e plus letter 1 d4 4f. Letter 1 d4 4e minus letter 1 d4 4f. How to given a difference of squares, factor it into binomials. Confirm that the first and last term are perfect squares. Write the factored form as letter 1 d4 4e plus letter 1 d4 4f, letter 1 d4 4e minus letter 1 d4 4f. Example 5, factoring a difference of squares. Factor 9 letter 1 d4 6 5 2 minus 25. Solution. Notice that 9x2 and 25 are perfect squares because 9 letter 1 d4 6 5 2 equals 3 letter 1 d4 6 5 2 and 25 equals 52. The polynomial represents a difference of squares and can be rewritten as 3 letter 1 d4 6 5 plus 5, 3 letter 1 d4 6 5 minus 5. Try it. 5 factor 81 letter 1 d4 6 6 2 minus 100. Q and A. Is there a formula to factor the sum of squares? No, a sum of squares cannot be factored. Factoring the sum and difference of cubes. Now, we will look at two new special products, the sum and difference of cubes. Although the sum of squares cannot be factored, the sum of cubes can be factored into a binomial and a trinomial. Letter 1 d4 4e 3 plus letter 1 d4 4f 3 equals letter 1 d4 4e plus letter 1 d4 4f. Letter 1 d4 4e 2 minus letter 1 d4 4e letter 1 d4 4f plus letter 1 d4 4f 2. Similarly, the difference of cubes can be factored into a binomial and a trinomial, but with different signs. Letter 1 d4 4e 3 minus letter 1 d4 4f 3 equals letter 1 d4 4e minus letter 1 d4 4f. Letter 1 d4 4e 2 plus letter 1 d4 4e letter 1 d4 4f plus letter 1 d4 4f 2. We can use the acronym SOAP to remember the signs when factoring the sum or difference of cubes. The first letter of each word relates to the signs. Same opposite always positive. For example, consider the following example. Letter 1 d4 6 5 3 minus 23 equals letter 1 d4 6 5 minus 2, letter 1 d4 6 5 2 plus 2 letter 1 d4 6 5 plus 4. the sign of the first two is the same as the sign between letter 1d465 3 minus 23. The sign of the 2x term is opposite the sign between letter 1d465 3 minus 23. And the sign of the last term, 4, is always positive. Sum and difference of cubes, we can factor the sum of two cubes as letter 1d44e 3 plus letter 1d44f 3 equals letter 1d44e plus letter 1d44f. Letter 1d44e 2 minus letter 1d44e letter 1d44f plus letter 1d44f 2, we can factor the difference of two cubes as letter 1d44e 3 minus letter 1d44f 3 equals letter 1d44e minus letter 1d44f. Letter 1d44e 2 plus letter 1d44e letter 1d44f plus letter 1d44f 2. How to given a sum of cubes or difference of cubes. Factor it. Confirm that the first and last term are cubes, a3 plus b3, or letter 1d44e 3 minus letter 1d44f3. For a sum of cubes, write the factored form as letter 1d44e plus letter 1d44f. Letter 1d44e 2 minus letter 1d44e letter 1d44f plus letter 1d44f2. For a difference of cubes, write the factored form as letter 1d44e minus letter 1d44f. Letter 1d44e 2 plus letter 1d44e letter 1d44f plus letter 1d44f2. Example 6, factoring a sum of cubes factor x3 plus 512. Solution: notice that x3 and 512 are cubes because 83 equals 512. Rewrite the sum of cubes as letter 1d465 plus 8, letter 1d465 2 minus 8 letter 1d465 plus 64. Analysis: after writing the sum of cubes this way, we might think we should check to see if the trinomial portion can be factored further. However, the trinomial portion cannot be factored, so we do not need to check. Try at 6 factor the sum of cubes, 216a3 plus b3. Example 7, factoring a difference of cubes factor, 8 letter 1d465 3 minus 125. Solution: notice that 8x3 and 125 are cubes because 8 letter 1d465 3 equals 2 letter 1d465 3 and 125 equals 53. Write the difference of cubes as 2 letter 1d465 minus 5, 4 letter 1d465 2 plus 10 letter 1d465 plus 25. Analysis: just as with the sum of cubes, we will not be able to further factor the trinomial portion. Try at 7 factor the difference of cubes, 1, 0, 0, 0 letter 1d465 3 minus 1. Factoring expressions with fractional or negative exponents, expressions with fractional or negative exponents can be factored by pulling out a GCF. Look for the variable or exponent that is common to each term of the expression and pull out that variable or exponent raised to the lowest power. These expressions follow the same factoring rules as those with integer exponents. For instance, 2x14 plus 5x34 can be factored by pulling out x14 and being rewritten as letter 1d465 14, 2 plus 5 letter 1d465 12. Example 8, factoring an expression with fractional or negative exponents, factor 3 letter 1d465. Letter 1d465 plus 2 minus 13 plus 4. Letter 1d465 plus 2, 23. Solution: factor out the term with the lowest value of the exponent. In this case, that would be letter 1d465 plus 2 minus 13. Letter 1d465 plus 2 minus 13, 3 letter 1d465 plus 4 letter 1d465 plus 2. Letter 1d465 plus 2 minus 13, 3 letter 1d465 plus 4 letter 1d465 plus 8. Letter 1d465 plus 2 minus 13, 7 letter 1d465 plus 8, factor out the GCF. Simplify. Try at 8 factor 2, 5 letter 1d44e minus 1, 34 plus 7 letter 1d44e, 5 letter 1d44e minus 1, minus 14. Media access: these online resources for additional instruction and practice with factoring polynomials. Identify GCF factor trinomials when it equals 1 factor trinomials, when it is not equal to 1 factor, sum or difference of cubes 1. 5 section exercises verbal 1. If the terms of a polynomial do not have a GCF, does that mean it is not factorable? Explain. 2. A polynomial is factorable, but it is not a perfect square trinomial or a difference of two squares. Can you factor the polynomial without finding the GCF? 3. How do you factor by grouping? Algebraic for the following exercises, find the greatest common factor. 4. 14 letter 1d465 plus 4 letter 1d465 letter 1d466 minus 18 letter 1d465 letter 1d466, 2 5. 49 letter 1d458 letter 1d44f, 2 minus 35 letter 1d458 aba, plus 77 ma 26. 30 letter 1d465, 3 letter 1d466, minus 45 letter 1d465 to letter 1d466, 2 plus 135 letter 1d465 letter 1d466, 3 7. 200 letter 1d45d, 3 letter 1d45a, 3 minus 30 letter 1d45d to m3, plus 40 m3 8. 36 letter 1d457, 4 letter 1d458, 2 minus 18 letter 1d457, 3 letter 1d458, 3, plus 54 letter 1d457 to k, 4 9. 6 letter 1d466, 4 minus 2 letter 1d466, 3, plus 3 letter 1d466, 2 minus letter 1d466, for the following exercises, factor by grouping. 10. 6 letter 1d465, 2, plus 5 letter 1d465 minus 4 11. 2 letter 1d44e, 2, plus 9 letter 1d44e minus 18 12. 6c2, plus 41c, plus 63 13. 6 letter 1d45b, 2 minus 19, letter 1d45b minus 11 14. 20 letter 1d464, 2 minus 47 letter 1d464, plus 24 15. 2 letter 1d45d, 2 minus 5 letter 1d45d minus 7, for the following exercises, factor the polynomial. 16. 7 letter 1d465, 2, plus 48 letter 1d465 minus 7 17. 10 letter 210e, 2 minus 9 letter 210e minus 9 18. 2 letter 1d44f, 2 minus 25 letter 1d44f minus 247 19. 9 letter 1d451, 2 minus 73 letter 1d451 plus 820. 90 letter 1d463, 2 minus 181 letter 1d463 plus 9021. 12 letter 1d461, 2 plus letter 1d461 minus 1322. 2 letter 1d45b, 2 minus letter 1d45b minus 1523. 16 letter 1d465, 2 minus 124. 25 letter 1d466, 2 minus 196 25. 121 letter 1d45d, 2 minus 169 26. 4 letter 1d45a, 2 minus 9 27. 361 letter 1d451, 2 minus 80, 128. 324 letter 1d465, 2 minus 121 29. 144 letter 1d44f, 2 minus 25 letter 1d450, 230. 16 letter 1d44e, 2 minus 8 letter 1d44e, plus 131. 49 and 2, plus 168n, plus 144 32. 121 letter 1d465, 2 minus 88 letter 1d465, plus 1633. 225 y2, plus 120y plus 1634. Letter 1d45a, 2 minus 20 letter 1d45a, plus 135. 25 letter 1d45d, 2 minus 120 letter 1d45d, plus 144 36. 36q2 plus 60q plus 25 for the following exercises, factor the polynomials. 37, x3 plus 2 16 38. 27 letter 1d466 3 minus 8 39. 125 a3 plus 340 340. Letter 1d44f, 3 minus 8, letter 1d451, 341. 64 letter 1d465, 3 minus 125 42. 729 q3 plus 1330 143. 125 r3 plus 1728 344. 4 letter 1d465. Letter 1d465 minus 1 minus 23 plus 3. letter 1d465 minus 1, 1345. 3 letter 1d450. 2 letter 1d450 plus 3 minus 14 minus 5. 2 letter 1d450 plus 3, 3446. 3 letter 1d461. 10 letter 1d461 plus 3. 13 plus 7 10 letter 1d461 plus 3, 4347. 14 letter 1d465. Letter 1d465 plus 2, minus 25 plus 5 letter 1d465 plus 2, 3548. 9 letter 1d466. 3 letter 1d466 minus 13, 15 minus 2, 3 letter 1d466 minus 13, 6549. 5 letter 1d467. 2 letter 1d467 minus 9, minus 32 plus 11, 2 letter 1d467 minus 9 minus 1250. 6 letter 1d451, 2 letter 1d451 plus 3, minus 16 plus 5 2 letter 1d451 plus 356. Real-world applications for the following exercises. Consider this scenario. Charlotte has appointed a chairperson to lead a city beautification project. The first act is to install statues and fountains in one of the city's parks. The park is a rectangle with an area of 98 letter 1d465 plus 105 letter 1d465 minus 27 m2, as shown in the figure below. The length and width of the park are perfect factors of the area. A rectangle that's textured to look like a field. The field is labeled L times W equals 98 times x squared plus 105 times x minus 27. 51. Factor by grouping to find the length and width of the park. 52. A statue is to be placed in the center of the park. The area of the base of the statue is 4x2 plus 12x plus 9m2. Factor the area to find the lengths of the sides of the statue. 53. At the northwest corner of the park, the city is going to install a fountain. The area of the base of the fountain is 9 letter 1d465 2 minus 25 m2. Factor the area to find the lengths of the sides of the fountain. For the following exercise, consider the following scenario. A school is installing a flagpole in the central plaza. The plaza is a square with side length 100 yd, as shown in the figure below. The flagpole will take up a square plot with area letter 1d465, 2 minus 6 letter 1d465, plus 9 yd2. A square that's textured to look like a field with a missing piece in the shape of a square in the center. The sides of the larger square are labeled 100 yards. The center square is labeled area. X squared minus 6 times x plus 9. 54. Find the length of the base of the flagpole by factoring. Extensions for the following exercises factor the polynomials completely. 55. 16 letter 1d465, 4 minus 200 letter 1d465, 2 plus 625 56. 81 letter 1d466, 4 minus 256 57. 16 letter 1d467, 4 minus 2, 401 letter 1d44e, 458. 5 letter 1d465, 3 letter 1d465 plus 2, minus 24 plus 12 letter 1d465 plus 8, 3259. 32 letter 1d465 3, plus 48 letter 1d465, 2 minus 162 letter 1d465, minus 243 minus 1. Learning objectives in this section, you will simplify rational expressions, multiply rational expressions, divide rational expressions, add and subtract rational expressions, simplify complex rational expressions. A pastry shop has fixed costs of $280 per week and variable costs of $9 per box of pastries. The shop's costs per week in terms of x, the number of boxes made, is 280 plus 9x. We can divide the costs per week by the number of boxes made to determine the cost per box of pastries. 280 plus 9 letter 1d465 letter 1d465. Notice that the result is a polynomial expression divided by a second polynomial expression. In this section, we will explore quotients of polynomial expressions. Simplifying rational expressions, the quotient of two polynomial expressions is called a rational expression. We can apply the properties of fractions to rational expressions. such as simplifying the expressions by canceling common factors from the numerator and the denominator. To do this, we first need to factor both the numerator and denominator. Let's start with the rational expression shown. x2 plus 8x plus 16x2 plus 11x plus 28, we can factor the numerator and denominator to rewrite the expression. Letter 1d465 plus 4, 2, letter 1d465 plus 4, letter 1d465 plus 7. Then we can simplify that expression by canceling the common factor, x plus 4. X plus 4x plus 7. How to given a rational expression, simplify it. Factor the numerator and denominator. Cancel any common factors. Example 1, simplifying rational expressions. Simplify letter 1d465, 2 minus 9 letter 1d465 2, plus 4 letter 1d465 plus 3. Solution, letter 1d465 plus 3, letter 1d465 minus 3, letter 1d465 plus 3. Letter 1d465 plus 1 letter 1d465 minus 3 letter 1d465 plus 1 factor the numerator and the denominator. Cancel common factor, x plus 3. Analysis, we can cancel the common factor because any expression divided by itself is equal to 1. Q and A, can the x2 term be cancelled in example 1? No. A factor is an expression that is multiplied by another expression. The x2 term is not a factor of the numerator or the denominator. Try it 1. Simplify letter 1d465 minus 6, letter 1d465, 2 minus 36. Multiplying rational expressions, multiplication of rational expressions, works the same way as multiplication of any other fractions. We multiply the numerators to find the numerator of the product, and then multiply the denominators to find the denominator of the product. Before multiplying, it is helpful to factor the numerators and denominators just as we did when simplifying rational expressions. We are often able to simplify the product of rational expressions. How to given two rational expressions, multiply them, factor the numerator and denominator, multiply the numerators, multiply the denominators, simplify. Example 2, multiplying rational expressions, multiply the rational expressions, and show the product in simplest form. Letter 1d465 2, plus 4 letter 1d465, minus 53 letter 1d465, plus 18 2 letter 1d465 minus 1 letter 1d465, plus 5 solution. Letter 1d465 plus 5. Letter 1d465 minus 1 3 letter 1d465 plus 6. 2 letter 1d465 minus 1. Letter 1d465 plus 5. Letter 1d465 plus 5. Letter 1d465 minus 1. 2 letter 1d465 minus 1 3 letter 1d465 plus 6. Letter 1d465 plus 5. Letter 1d465 plus 5. Letter 1d465 minus 1, 2 letter 1d. Factor the numerator and denominator. Multiply numerators and denominators. Cancel common factors to simplify. Try it to multiply the rational expressions and show the product in simplest form. Letter 1d465 2, plus 11 letter 1d465, plus 30 letter 1d465 2, plus 5 letter 1d465. Plus 6 letter 1d465 2, plus 7 letter 1d465, plus 12 letter 1d465 2, plus 8 letter 1d465, plus 16. Dividing rational expressions, division of rational expressions, works the same way as division of other fractions. To divide a rational expression by another rational expression, multiply the first expression by the reciprocal of the second. Using this approach, we would rewrite 1 letter 1d465 divided by letter 1d465 23 as the product 1 letter 1d465 3 letter 1d465 2. Once the division expression has been rewritten as a multiplication expression, we can multiply as we did before. 1 letter 1d465 3 letter 1d465 2 equals 3 letter 1d465 3. How to given two rational expressions, divide them. Rewrite as the first rational expression multiplied by the reciprocal of the second. Factor the numerators and denominators, multiply the numerators, multiply the denominators, simplify. Example 3, dividing rational expressions, divide the rational expressions, and express the quotient in simplest form. 2 letter 1d465 2, plus letter 1d465 minus 6, letter 1d465 2 minus 1, divided by letter 1d465 2 minus 4 letter 1d465 2, plus 2 letter 1d465 plus 1 solution. 2 letter 1d465 2 plus letter 1d465 minus 6 letter 1d465 2 minus 1 letter 1d465 2 plus 2 letter 1d465 plus 1 letter 1d465 2 minus 4. 2 letter 1d465 minus 3. Letter 1d465 plus 2. Letter 1d465 plus 1. Letter 1d465 minus 1. Letter 1d465 plus 1. 2 letter 1d465 plus 2. Letter 1d46. As multiplication. Factor, multiply. Cancel common factors to simplify. Try it 3. Divide the rational expressions and express the quotient in simplest form. 9 letter 1d465 2 minus 163 letter 1d465 2 plus 17 letter 1d465 minus 28 divided by 3 letter 1d465 2 minus 2 letter 1d465 minus 8 letter 1d465 2 plus 5 letter 1d465 minus 14. Adding and subtracting rational expressions. Adding and subtracting rational expressions works just like adding and subtracting numerical fractions. To add fractions, we need to find a common denominator. Let's look at an example of fraction addition. 524 plus 140 equals 25,120 plus 312,028,120,730. We have to rewrite the fractions so they share a common denominator before we are able to add. We must do the same thing when adding or subtracting rational expressions. The easiest common denominator to use will be the least common denominator, or LCD. The LCD is the smallest multiple that the denominators have in common. To find the LCD of two rational expressions, we factor the expressions and multiply all of the distinct factors. For instance, if the factored denominators were and letter 1d465 plus 4, letter 1d465 plus 5, then the LCD would be letter 1d465 plus 3, letter 1d465 plus 4, letter 1d465 plus 5. Once we find the LCD, we need to multiply each expression by the form of one that will change the denominator to the LCD. We would need to multiply the expression with a denominator of by x plus 5 and the expression with a denominator of by x plus 3. How to given two rational expressions, add or subtract them. Factor the numerator and denominator. Find the LCD of the expressions. Multiply the expressions by a form of one that changes the denominators to the LCD. Add or subtract the numerators. Simplify. Example 4. Adding rational expressions. Add the rational expressions. 5x plus 6y solution. First, we have to find the LCD. In this case, the LCD will be letter 1d465 letter 1d466. We then multiply each expression by the appropriate form of 1 to obtain letter 1d465 letter 1d466 as the denominator for each fraction. 5 letter 1d465 letter 1d466 letter 1d466 plus 6 letter 1d466 letter 1d465 letter 1d465 5 letter 1d466 letter 1d465 letter 1d466 plus 6 letter 1d465 letter 1d465 letter 1d466. Now that the expressions have the same denominator, we simply add the numerators to find the sum. 6 letter 1d465 plus 5 letter 1d466 letter 1d465 letter 1d466. Analysis. Multiplying by letter 1d466 letter 1d466 or letter 1d465 letter 1d465 does not change the value of the original expression because any number divided by itself is 1. And multiplying an expression by 1 gives the original expression. Example 5. Subtracting rational expressions. Subtract the rational expressions. 6 letter 1d465 2 plus 4 letter 1d465 plus 4 minus 2 letter 1d465 2 minus 4 solution. 6 letter 1d465 plus 2 minus 2 letter 1d465 plus 2 letter 1d465 minus 2 6 letter 1d465 plus 2 letter 1d465 minus 2 letter 1d465 minus 2 minus 2 letter 1d465 plus 2 letter 1d465 minus 2 letter 1d465 plus 2 letter 1d465 plus 26 letter 1d465 minus 2 letter 1d465 plus 2, 2. Multiply each fraction to get LCD as denominator. Multiply, apply distributive property. Subtract, simplify. Q and A. Do we have to use the LCD to add or subtract rational expressions? No. Any common denominator will work, but it is easiest to use the LCD. Try it for subtract the rational expressions. 3 letter 1d465 plus 5 minus 1 letter 1d465 minus 3. Simplifying complex rational expressions. A complex rational expression is a rational expression that contains additional rational expressions in the numerator, the denominator, or both. We can simplify complex rational expressions by rewriting the numerator and denominator as single rational expressions and dividing. The complex rational expression a1b plus c can be simplified by rewriting the numerator as the fraction a1 and combining the expressions in the denominator as 1 plus letter 1d44f letter 1d450 letter 1d44f. We can then rewrite the expression as a multiplication problem using the reciprocal of the denominator. We get letter 1d44e, 1 letter 1d44f, 1 plus letter 1d44f letter 1d450, which is equal to letter 1d44e letter 1d44f, 1 plus letter 1d44f letter 1d450. How to given a complex rational expression, simplify it. Combine the expressions in the numerator into a single rational expression by adding or subtracting. Combine the expressions in the denominator into a single rational expression by adding or subtracting. Rewrite as the numerator divided by the denominator. Rewrite as multiplication. Multiply. Simplify. Example 6. Simplifying complex rational expressions. Simplify. Solution. Begin by combining the expressions in the numerator into one expression. Letter 1d466, letter 1d465, letter 1d465, plus 1 letter 1d465, letter 1d465, letter 1d466, letter 1d465, plus 1 letter 1d465, letter 1d465, letter 1d466, plus 1 letter 1d465. Multiply by letter 1d465, letter 1d465 to get LCD as denominator. Add numerators. Now the numerator is a single rational expression and the denominator is a single rational expression. We can rewrite this as division and then multiplication. Letter 1d465, letter 1d466, plus 1 letter 1d465, divided by letter 1d465, letter 1d466, letter 1d465, letter 1d466, plus 1 letter 1d465, letter 1d466, letter 1d465, letter 1d466. Letter 1d465, letter 1d466, plus 1 letter 1d465 to rewrite as multiplication. Multiply. Try it 5. Simplify. Letter 1d465, letter 1d466, minus letter 1d466, letter 1d465, letter 1d466, Q and A. Can a complex rational expression always be simplified? Yes, we can always rewrite a complex rational expression as a simplified rational expression. Media access these online resources for additional instruction and practice with rational expressions. Simplify rational expressions, multiply and divide rational expressions, add and subtract rational expressions, simplify a complex fraction, 1/6 section, exercises verbal 1. How can you use factoring to simplify rational expressions? 2. How do you use the LCD to combine two rational expressions? 3. Tell whether the following statement is true or false and explain why. You only need to find the LCD when adding or subtracting rational expressions. Algebraic for the following exercises, simplify the rational expressions. 4. Letter 1d465, 2 minus 16, letter 1d465, 2 minus 5, letter 1d465, plus 4, 5. y2 plus 10y plus 25y2 plus 11y plus 36. 6. Letter 1d44e, 2 minus 24, letter 1d44e, plus 246, letter 1d44e, 2 minus 24, 7. 9b2, plus 18b, plus 93b, plus 38. Letter 1d45a, minus 12, letter 1d45a, 2 minus 144, 9. 2. Letter 1d465, 2, plus 7, letter 1d465, minus 44, letter 1d465, 2. Plus 2, letter 1d465, minus 210. 6. Letter 1d465, 2, plus 5 letter 1d465 minus 43 letter 1d465 2 plus 19 letter 1d465 plus 2011 letter 1d44e2 plus 9 letter 1d44e plus 18 letter 1d44e2 plus 3 letter 1d44e minus 1812 3 letter 1d450 2 plus 25 letter 1d450 minus 183 letter 1d450 2 minus 23 letter 1d450 plus 1413 12 letter 1d45b2 minus 29 letter 1d45b minus 828 letter 1d45b2 minus 5 letter 1d45b minus 3 for the following exercises. Multiply the rational expressions and express the product in simplest form. 14. Letter 1d4652 minus letter 1d465 minus 62 letter 1d4652 plus letter 1d465 minus 62 letter 1d4652 plus 7 letter 1d465 minus 15 letter 1d4652 minus 9 15 letter 1d450 2 plus 2 letter 1d450 minus 24 letter 1d450 2 plus 12 letter 1d450 plus 36 letter 1d450 2 minus 10 letter 1d450 plus 24 letter 1d450 2 minus 8 letter 1d450 plus 1616 2 letter 1d4512 plus 9 letter 1d451 minus 35 letter 1d4512 plus 10 letter 1d451 plus 21 3 letter 1d4512 plus 2 letter 1d451 minus 213 letter 1d4512 plus 14 letter 1d451 minus 4917 10 letter 210e2 minus 9 letter 210e minus 92 letter 210e2 minus 19 letter 210e plus 24 letter 210e2 minus 16 letter 210e plus 645 letter 210e2 minus 37 letter 210e minus 2418 6 letter 1d44f2 plus 13 letter 1d44f plus 64 letter 1d44f 2 minus 9 6 letter 1d44f 2 plus 31 letter 1d44f minus 3018 letter 1d44f 2 minus 3 letter 1d44f minus 1019 2 letter 1d4512 plus 15 letter 1d451 plus 254 letter 1d451 2 minus 25 2 letter 1d451 2 minus 15 letter 1d451 plus 2525 letter 1d451 2 minus 120 6 letter 1d4652 minus 5 letter 1d465 minus 5015 letter 1d4652 minus 44 letter 1d465 minus 2020 letter 1d4652 minus 7 letter 1d465 minus 62 letter 1d4652 plus 9 letter 1d465 plus 1021 letter 1d4612 minus 1 letter 1d4612 plus 4 letter 1d461 plus 3 letter 1d4612 plus 2 letter 1d461 minus 15 letter 1d4612 minus 4 letter 1d461 plus 322 2 letter 1d45b2 minus letter 1d45b minus 156 letter 1d45b2 plus 13 letter 1d45b minus 512 letter 1d45b2 minus 13 letter 1d45b plus 34 letter 1d45b2 minus 15 letter 1d45b plus 923 36 letter 1d465 2 minus 256 letter 1d465 2 plus 65 letter 1d465 plus 53 letter 1d465 2 plus 32 letter 1d465 plus 2018 letter 1d465 2 plus 27 letter 1d465 plus 10 for the following exercises. Divide the rational expressions. 24. 3 letter 1d4662 minus 7 letter 1d466 minus 62 letter 1d466 2 minus 3 letter 1d466 minus 9 divided by letter 1d466 2 plus letter 1d466 minus 22 letter 1d466 2 plus letter 1d466 minus 325 6 letter 1d45d2 plus letter 1d45d minus 128 letter 1d45d2 plus 18 letter 1d45d plus 9, divided by 6 letter 1d45d, 2, minus 11 letter 1d45d, plus 42 letter 1d45d 2, plus 11 letter 1d45d minus 626. Letter 1d45e 2, minus 9 letter 1d45e 2, plus 6 letter 1d45e plus 9, divided by letter 1d45e 2, minus 2 letter 1d45e minus 3 letter 1d45e 2, plus 2 letter 1d45e minus 327. 18 letter 1d4512, 2, plus 77 letter 1d451 minus 1827 letter 1d451, 2 minus 15 letter 1d451, plus 2, divided by 3 letter 1d4512, plus 29 letter 1d451 minus 449 letter 1d451, 2 minus 15 letter 1d451, plus 428. 16 letter 1d4652, plus 18 letter 1d465 minus 5500, 32 letter 1d4652 minus 36 letter 1d465 minus 11, divided by 2 letter 1d4652, plus 17 letter 1d465, plus 304 letter 1d4652, plus 25 letter 1d465, plus 629. 144 letter 1d44f, 2 minus 2572 letter 1d44f, 2 minus 6 letter 1d44f minus 10, divided by 18 letter 1d44f, 2 minus 21 letter 1d44f, plus 536 letter 1d44f, 2 minus 18 letter 1d44f minus 1030. 16 letter 1d44e 2 minus 24 letter 1d44e, plus 94 letter 1d44e 2, plus 17 letter 1d44e minus 15, divided by 16 letter 1d44e 2 minus 94 letter 1d44e 2, plus 11 letter 1d44e plus 631. 22 letter 1d4662, plus 59 letter 1d466, plus 1012 letter 1d4662, plus 28 letter 1d466 minus 5, divided by 11 letter 1d4662, plus 46 letter 1d466, plus 824 letter 1d4662, minus 10 letter 1d466, plus 132. 9 letter 1d4652, plus 3 letter 1d465, minus 203 letter 1d4652 minus 7 letter 1d465, plus 4, divided by 6 letter 1d4652, plus 4 letter 1d465 minus 10, letter 1d4652, minus 2 letter 1d465, plus 1 for the following exercises. Add and subtract the rational expressions, and then simplify. 33. 4x plus 10y 34. 122 letter 1d45e minus 63 letter 1d45d 35. 4 letter 1d44e plus 1 plus 5 letter 1d44e minus 336. Letter 1d450 plus 23 minus letter 1d450 minus 40 437. Letter 1d466 plus 3 letter 1d466 minus 2 plus letter 1d466 minus 3 letter 1d466 plus 138. Letter 1d465 minus 1 letter 1d465 plus 1 minus 2 letter 1d465 plus 32 letter 1d465 plus 139. 3 letter 1d467 letter 1d467 plus 1 plus 2 letter 1d467 plus 5 letter 1d467 minus 240. 4 letter 1d45d letter 1d45d plus 1 minus letter 1d45d plus 14 letter 1d45d 41. Letter 1d465 letter 1d465 plus 1 plus letter 1d466 letter 1d466 plus 1 for the following exercises. Simplify the rational expression. 42. 6 letter 1d466 minus 4 letter 1d465 letter 1d466 43. 2 letter 1d44e plus 7 letter 1d44f letter 1d44f 44. Letter 1d465 4 minus letter 1d45d 8 letter 1d45d 45. 3a plus b 62 b3a 46. 3 letter 1d465 plus 1 plus 2 letter 1d465 minus 1 letter 1d465 minus 1 letter 1d465 plus 147. Letter 1d44e letter 1d44f minus letter 1d44f letter 1d44e letter 1d44e plus letter 1d44f letter 1d44e letter 1d44f 48. 2x3 plus 4x7 x2 49. 2 letter 1d450 letter 1d450 plus 2 plus letter 1d450 minus 1 letter 1d450 plus 12 letter 1d450 plus 1 letter 1d450 plus 150. Letter 1d465 letter 1d466 minus letter 1d466 letter 1d465 letter 1d465 letter 1d466 plus letter 1d466 letter 1d465 real-world applications 51. Brenda is placing tile on her bathroom floor. The area of the floor is 15 letter 1d465 2 minus 8 letter 1d465 minus 7 ft2. The area of one tile is letter 1d465 2 minus 2 letter 1d465 plus 1 ft2. To find the number of tiles needed, simplify the rational expression. 15 letter 1d465 2 minus 8 letter 1d465 minus 7 letter 1d465 2 minus 2 letter 1d465 plus 1. A rectangle that's labeled area equals 15 times x squared minus 8 times x minus 7. 52. The area of Luan's yard is 25 letter 1d465 2 minus 625 ft2. A patch of sod has an area of letter 1d465 2 minus 10 letter 1d465 plus 25 ft2. Divide the two areas and simplify to find how many pieces of sod Luan needs to cover her yard. 53. Elroy wants to mulch his garden. His garden is x2 plus 18x plus 81 ft2. One bag of mulch covers letter 1d465 2 minus 81 ft2. Divide the expressions and simplify to find how many bags of mulch Elroy needs to mulch his garden. Extensions for the following exercises: perform the given operations and simplify. 54. Letter 1d465 2 plus letter 1d465 minus 6, letter 1d465 2 minus 2 letter 1d465 minus 3 2 letter 1d465 2 minus 3 letter 1d465 minus 9 letter 1d465 2 minus letter 1d465 minus 2 divided by 10 letter 1d465 2 plus 27 letter 1d465 plus 18 letter 1d465 2 plus 2 letter 1d465 plus 1. 55. 3 letter 1d466 2 minus 10 letter 1d466 plus 33 letter 1d466 2 plus 5 letter 1d466 minus 2 2 letter 1d466 2 minus 3 letter 1d466 minus 202 letter 1d466 2 minus letter 1d466 minus 15 letter 1d466 minus 456. 4 letter 1d44e plus 12 letter 1d44e minus 3 plus 2 letter 1d44e minus 32 letter 1d44e plus 34 letter 1d44e 2 plus 9 letter 1d44e 57. Letter 1d465 2 plus 7 letter 1d465 plus 12 letter 1d465 2 plus letter 1d465 minus 6 divided by 3 letter 1d465 2 plus 19 letter 1d465 plus 288 letter 1d465 2 minus 4 letter 1d465 minus 24 divided by 2 letter 1d465 2 plus letter 1d465 minus 33 letter 1d465 2 plus 4.